All right. I think we should be live. I think people should be able to hear me as well. So this is the audio check. Let me know if you can hear me. Just throw something in chat, like we can't hear you or we can hear you. Wait, the first one's going to be impossible because if you can't hear me, then you can't hear my request. All right. Moderator says yes. It's working. Good. Um, perfect. So yeah, we have a couple of minutes left. So I don't know exactly what we want to do at this time. Check, double check. Yeah, no, seems to be working. Um, so we will discuss the assignments, of course, but are there any questions to the assignments before we start? Like questions, remarks, praise, complaints, too hard, too easy. So let me know. Unfortunately, we couldn't do it in person today. So yeah, I'm a little bit sad about that. I think it's always good that assignments should be done in person so that people can get direct help. One thing that I would like to mention is this, that if you are a student and you are having issues with the YouTube chat for some reason, I think I missed a step where Notepad++ and R were connected or something. Well, they're not connected. You just have to open two windows. So the way that I always show you guys, right? That's the way that it just looks on stream. So I just have like the two individual windows open, and I generally just write my code in Notepad++, and then I just copy paste it to R to have it run. Um, so that's the way that I do it. But yeah, we have some remarks yesterday as well about the fact that or not yesterday, but last stream, that it is kind of confusing what you're. Okay, so do we use them separately? Yes, my Notepad++ doesn't color what I type. It's all gray. Okay, so this is one of these issues which occurs when you don't save the file with the correct extension. Let me see if I can actually make a nice screenshot from it. And I will just make a screenshot and then I will do paint. And then we're just going to select a little part from it like this. And then we say file, new, don't save, put it in there. Good. So now we have the screenshot. And then I can make a slide about that. So thank you. I will show you how to have it color the text. Because if you save it with an extension, which is .r, so not saving the file as answers01.txt, but saving it as answers01.r, then Notepad++ will use the proper highlighting for it. If not, you can actually force it to do the proper highlighting. If you look at the Notepad++, there's File, Edit, Search, View. Yeah, you can also set your language via the syntax menu. Yeah, so that's the language option. Let me just quickly... No, I can't edit it because we're already streaming. Um, is there another way of doing this? Oh, no, I can still edit it. Good, because we're still in the first slide layout. So I just have a small screenshot, which I'm just gonna put there. What did I miss? You didn't miss anything yet. We just started, so just taking questions, random questions from random people. So, well, they should be. Oh yeah, the sound check. Yeah, you missed the sound check, which obviously is working. Otherwise, you would not hear me. Um, we did not do a music check though. So But yeah, no, Jolie Sana, I will definitely. I updated the slide for the assignment, so I will just show you guys how you can do that. I don't think I can show you live because I think the screen capture that I'm doing for Notepad++ doesn't capture all of the menus and stuff. No visual of Danny. You guys want to see me? That's not an issue. We can just switch to the lecture layout, and then I'm here. So Visual Danny. But now you have to watch me for like 4 minutes. Like generally, I don't want to start the stream too early, but it's good to make sure that everything works before 2. How do I save my R console? You mean the output of the R console, or just the session that you did? Um, because saving the R console, so saving the history, there's an option in R for that. So let me see. There's a file. Don't. Yeah, I will always advise people to not save anything from R, but sometimes it is useful if you're dealing with like big data and you need the data on like 10 different computers because you're using a cluster. Uh, Frog, I sent you an email, but I still can't join the Moodle group even with password. Okay. That's something that we can fix. If you Frog, are you from the HU? Because let me check my email. Did you send it to my Gmail or did you send it to my HU account? Uh, Let me search through my Gmail and I will also log into my webmail just so that we can see if the email is there. All right, I can't find your email. Could you quickly send your email again? Because I can add you to Moodle manually if you're part of the HU. So if you have a HU registration, then I should be able to easily add you. I send it to your Gmail. All right. Once the Moodle is up, so Moodle is not the best search term for this thing. Uh, I need to know your real name for this to be able to do this. Because Frog is not gonna work searching through my Gmail, and I talk a lot about Moodle, apparently. So when I just search Moodle, I come up with like 150 different emails that I have to go through. Um, so yeah, do send the email again, and just say I'm Frog so that I can at least like figure out that you belong to the email, right? And then we can just do that, and then we can get you into the Moodle. Because in theory, let me see. In theory, everyone should be able to join the Moodle, even when you're not, even if you're not from the HU or anything, because. All right, just got your email. Thanks. No, that's not your email. Uh, all right, yeah. All right, so we have another person signing up for the course, apparently. Yes, you can, and we're doing the lecture now. So please join us at. And then let's get the link of the live stream. Um, all right, so it's 2. So officially we started now, but I'm just gonna do a couple more things. So let me go to my own channel. It's always difficult. Like first couple of lectures always have like a lot of these like household announcement thingies that you run into. Oh, that's horrible. Don't give me the secondary sound. Yeah, I joined as guest. Yeah, our course 2022. Yeah, and then you have to have the right link to the. So do you have the link for people that are joining as guests? Because that would be good. Because I think for the link that I send around is the link for people who can log into Moodle. For the people who can't log into the Moodle, there's another link. I'm heavily looking through my email to see where the link is. See, because if I go to Moodle myself, right, and then I log in to get the link to my course, that's this one, right, that's everything there. And then this is my course, and then I open a porno browser, and then I give the course. Yeah, so it's the enroll link. So if you go here, yeah, so if you go to this link and then you use the password rcourse 2022, so exactly like Jolie-san put it in chat, then everything should work. Because then you do have to use the lowest link. Let me show you that. Because I do have, of course, the opportunity to show you guys the Firefox. So let's show you guys Firefox. So, crap, I have to log out, of course. Because if I'm logged in, then it doesn't work. So you go to the link that I just put into the chat. Then here you have the course, right? Then you have the self-enrollment. But for self-enrollment, you need to be part of the HU. But if you just want to see the Moodle, you can just go to Gastzugang, and then here you just click the key. So the key, the R course 2020, 2022, and then you just click Speichern, and then you should be going into the course. Although I typed it in wrong, and then yeah, and then it should say here, Sie betrachten diesen Kurs gerade als Guest. So you're currently as a guest, but then at least you can like join the files and get the books and these kinds of things. So yeah, do try. And would it be possible for you to copy your R console into e.g. Notepad++ after each session and upload it to Moodle? No, I'm not going to do that. I'm going to give you my answers. So we'll go through my answers, and then I will upload the R file to Moodle, and then you can just download my R file. Because I generally don't use the console, right? I'm not interested in the output. The output is just the answer, but it's not about the answer, it's about writing the code, right? So the code is the thing. Okay, good. So Frog was able to enter, and we're all here. I think like 21, 22 of us, which is still not everyone, but at least enough. So let's start. So first slide. So I hope everyone appreciates the effort that I put in this beautiful drawing. I showed it to my colleagues, and their first reaction was, "What is the magic mushroom doing on the introductory slide?" And it's not a magic mushroom, right? It's the summer semester, so it's a beach umbrella. It's not a magic mushroom. It looks like a magic mushroom because the sun is also looking a little bit sketchy, but anyway. So, very quick recap of what we did last week. So, the quick recap of last week is we used R as a calculator, right? So, you can just type in things. And then we discussed very, very extensively all of the different types of data that there are in R. So, a logical is something which is either true or false. A numeric is a numerical value, so that can be 1, 2, 3, 4, but also something like 5.6 or 7.9. Characters are what in other programming languages are called strings. So those are character constants. So these are all of the things between the double air quotes. Furthermore, we have vectors and lists. So a vector is a more or less statistical type where everything in the vector is of the same type. So you can have a logical vector, a numeric vector, and a character vector. And lists, like we discussed, are things which you can store anything in. So it's kind of a general array. So hey, it's different things, and I can, in the first element I can put a matrix, in the second element I can put another list, and in the third element I can put a vector. A matrix is again a mathematical type, right? So it's a for example, a numeric matrix containing only numbers, and then we have data frames which are related to the list. So a data frame is a data type which allows you to a two-dimensional data type like a matrix, and then every column can have a different type. And then we talked about indexing data so that you can get the first element from a vector by using square brackets. And we also talked about the fact that the same thing works for matrices, right? So you have only single square brackets, and then you can select the first column or the first row, or 10 columns or 10 rows. And the double square bracket, we discussed this, is for lists. So only lists have this double square bracket system. And then furthermore, we actually took things like we actually went through several functions which allows you to generate lists of numbers, which is things like sec for generating a sequence, and rep for repeating a single element or multiple elements. And then we also talked about the double point operator, which is kind of the sec operator, but then always setting the step size to 1. So this is a vector of 1 to 20. So that's kind of the short recap from last week. All right, so the assignment. So we had a question, so I added this little screenshot here. So if you want to have code highlighting, you can go and click on language, and then you scroll down, and then there should be R as a language. So, and of course you can click any other language, but then it will use different colors. So if you want to use the same color scheme as me, then you have to use the R highlighting for your language. Again, I wanted to mention, if you have any chat issues on YouTube, then just join the Zoom meeting that we have running in parallel. The link is the same link as the previous time. So it's every week it will be the same Zoom link. So there's no magic there, no things that are generated. And I'm monitoring both chats, so we currently have one person in the Zoom, which is okay. But you can ask your questions there as well, if you don't want to have your questions, for example, pop up on YouTube later on. So the room issue, I wanted to say a little bit of things about that, but I didn't get any solution yet, unfortunately. So I hope that next week we can do an in-person lecture, because that would be great. And we have to figure out like the logistics of it, but I will mail you guys if I know more. So unfortunately here I'm more or less stuck with the Verwaltung, and if the Verwaltung is ignoring my emails, then I can't really do anything. Good. So with that being said and done, we will discuss assignment 1. So I will not read the entire question. I will just let you guys know what the question was and then what my answer was. So let me first show you my answers. Right, so here I have my Notepad++. So hey, you can see that by all of the little links at the, all of the little icons at the top. And besides that, of course, it is saved as with a file name called answers01-introduction.r, because the kind of short name of the lecture last week was introduction. Of course, answers01.r would be fine as well. But make sure that when you make a file, that the file name is meaningful, right? Because in programming, it's very important to be concise and precise. So by naming things answers or answers to the lecture, right, that's not descriptive enough. So besides that, make sure that the extension is .r, because then Notepad++ will automatically detect it, and then you don't have to manually set your language. So I always start by doing a header, just for me to know who made the file when I edit it last. But not only that, make sure that you add a copyright statement. In programming, because you are writing code, it is your code, and in future you might run into issues where people steal your code, right? And then by having a copyright statement at the top, hey, you can make sure that at least you're kind of covered there. If you really want to be covered, you have to, of course, share your code in some way. So generally, you use a version control system for that, to kind of make sure that you have an official timestamp saying that at this point in time, I wrote this code. It hasn't happened to me a lot, but I did have some issues in the past with people using my code and not crediting me in their publications that they wrote out of it. So it is not something that is very common in academia, but it is something that sometimes does occur. So be aware of that. Good. So the first couple of questions were to use R as a calculator, right? So, and in this case, I always make sure that I have a comment saying which question I'm answering. So this is question 1A, and the first question was to add 1234 to 4567, right? So I just do that by doing this plus that. So, and then for me, the question is answered, right? In this case, I'm not even going to copy it in R because I know that this should work, right? So I'm not going to check it at this point. And then the next one was to do a subtraction and an addition. So it's just some number 100,456 minus 3,350 plus 23. And then 1C was to take the natural logarithm. So this is the ln function normally, but in R it's called the log, because the log function standard has the e value as the base of the logarithm. If we wanted to take a 10 log, we would write log 10. If we wanted to do a 2 log, so with the base of 2, we can use log 2. But in this case it's just log, because that's the natural logarithm. 1D is dividing, so take a number, divide it by another number. 1E is to take a number and multiply it by another number. And then we go into the Euclidean division. So Euclidean division is division by whole numbers, so it's integer division. So it will never give you a number which has a fraction. So 5.7 is not an option, but 7.8 is. And then in 1G, I ask you how do you take the square root of a negative number, because R has built-in support for for taking the square root of negative numbers, so working with complex numbers. But the way to do this in R is to say square root minus 8 plus 0i. So you have to add this plus 0i, saying that there is no imaginary part to this number. Because only then will R realize that, oh, you want to use complex numbers, so it switches internally and says, well, now I can take the square root. So let's go to R and let's copy paste in the answer. So this is the reason why I don't like saving my R session or taking my R history, because R, when I copy paste it, it will always put these larger than symbols in front of it, right? And then my code won't run, because like the larger than symbol won't work, because that's just the input symbol that R uses, or that R uses to signify that there is an input symbol. Question in chat. Okay, that's not a question. You don't need to be sorry, Shia. That's okay. Like, the issues happen with the internet, so internet issues are never a big issue. All right, so let me go to R. So I'm going to press the button, and then I'm just going to copy my answers to question 1A. So I'm just going to go to Notepad, right? So in Notepad, I just select it. I press Control A, or not Control A, I select it in this case. I press Control C to copy it, and then I go to R, and in R, I just say paste. So I just do Control V. Right, so now you can see why, because now if I would save my history, or I would go to R and copy paste this in my answers, then this won't work, right? Because if I do this as a command in R, then it says error, right? It doesn't expect this larger than symbol to be there. So it is very, very important that you write code which you can just copy paste in, because the code itself should run from beginning to end without having any issues. So when you would write it down slightly differently, or you would just save the R history, then that doesn't work. And one thing that I would like to stress is that never ever type into R directly. It works for these small assignments. Also for the next batch of assignments, which belongs to this lecture, it will still work. But we are here to learn how to do data analysis, right? So that means loading in data, doing for loops, doing while loops, and making stuff out of your data. So very quickly code will become large, and code will be dependent on each other. So we will start using code blocks. And then you cannot type that into R anymore directly. You have to first type the code and then run the code in R. So I would like to stress that always separate out the running of the code in the R GUI and writing the code in an editor. And one of the things that RStudio does is in RStudio you have this clear separation. So you have a text editor on the top and then you have the R window on the bottom. But try to avoid typing things into R directly. Always use the Notepad++ window. It's just going to help you in the long run. All right, so question number 2. So question number 2 is a little bit of practicing with vectors. So one of the things that one of the questions was, let me actually pull up the questions because I opened so many windows that I don't know where the questions went. That's that I opened. Oh, here, there we have it. All right, so question number 2. So question number 2 is vectors. For these exercises, store the result each time in a variable vector2a, vector2b, unless specified otherwise. So the first question was, use the C operator to create a vector from 1 to 10. So you can do this in 2 different ways, right? So my way of doing it was just being, well, not stupid, but by being kind of explicit about it, right? So I say combine these numbers here into a vector, right? So just say 1, 2, 3, 4, 5 and just type them all in. Of course, I could have saved myself a lot of typing because the same thing I could have done and kind of cheating by just using the double point operator, right? So, and then in theory, the C is not necessary because 1 double point 10 will automatically create a vector. But since the assignment was to use the C version or to use the C function, it also works, right? So this also answers the question. It saves you a little bit of typing, but it's not exactly what I wanted. But so my preferred answer to vector 2a to question 2a would be to make a vector 2a, say just combine all the numbers manually and just type them in. All right, question. Can you explain 1g again? I tried x is -8 and then square is, yeah. So if we go to R, right, and I'm going to do something which I just told you to not do, is to type it in, right? But if I would just say square root of -8, right, then it will say NaN, not a number. Because this is true. In normal mathematics, we cannot take the square root of a negative number. This is an undefined quantity, right? Because the square root is defined as multiply 2 numbers together, and then you get the power, and then the inverse of the power is the square root, so that means separating out these 2 numbers again. So the +0i stands for 0 imaginary units. So mathematics used to be based on normal numbers, but then at a certain point in time, someone came up with the idea it would be really nice to be able to take the square root of a negative number because it's useful in mathematics because you can just continue calculating then instead of getting stuck. So after that, kind of mathematics branched out into 2 different fields. So you have normal mathematics, which uses normal numbers, and then you have complex mathematics, which uses complex numbers. And you have to tell R that you are using a complex number, right? So the square root of -8 plus 0i now gives you an answer, right? So the square root of -8 plus 0i is actually 0 real units, so it's 0 plus, and then here you have the imaginary part, right? So this is the part that people just come up with to make it work. Because if you would do the opposite, right, and you would take this number, right, and now do it to the power of 2, then it will say that it is -8 or very close to -8, right? It rounds down a little bit because it's not exact, because there's no real. But if you take -4, right, then you would see that there's 2 imaginary units. So it's just a different way of dealing with numbers, which is very important when you do springs and slings and planets surrounding the solar system. All of these things generally involve mathematics, which at a certain point you need to take the square root of a negative number to just continue with the formula. And then, in the end, you only report the real part of the number. Generally, you don't report the imaginary part. But it's just to make square rooting negative numbers work. Um, as a confession, I have not really used this at all. I think I used it like 2 times in the 14 years that I've been programming. And that was just for very, very specific use case where we did something with like orbital momentum of planets and stuff. All right, back to question 2. So hey, you can just say make a vector, put these numbers in, and you use the C function to combine them together, and then you have to use the round brackets to kind of say this is where the function begins and this is where the function parameters end. Right, so that's how it works. Then we do the same thing again, but now using the double point operator. So the double point operator is like the sec function, where we have a step by of 1. So this just means 1 to 11 to 20. Right, so again 10 numbers. We store this in vector 2b. Vector 2c is then, the question was use the sec function to go from 1 to 100 stepping by 5. So that's what we're doing here. So I'm using the sec function. I say go from 1 to 100 and then every time step by 5 units. And then the next one is a little bit tricky, and I think that this is the assignment, or this is the part where most people kind of get stuck on the assignment, and that is when we are talking about the even letters, because it is an uncommon term, right? It uses something from mathematics, even numbers, like 2 is even because it can be divided, and when you divide it by 2, there is no remainder. That's kind of the definition of an even number. You also have odd numbers, right? So 1, 3, 5, those are odd numbers. 2, 4, 6, those are the even numbers. But I told you that R has a lot of built-in constants, right? So letters is a vector. It is a built-in vector which contains all of the letters of the Roman alphabet. And you can then say, well, from letters, and then you can use the square brackets to do a selection from this vector. And then which letters do we want to select? Well, we want to select the second letter, the fourth letter, the sixth letter, the eighth letter, and so on, all the way to 26, right? Because there's 26 letters in the alphabet. So we can use the sec function to generate a vector which contains the numbers 2, 4, 6, all the way up to 26 by doing sec 2 to 26 by 2. And then we just select this directly from the letters vector. So let me run this code for you guys in R. So let me copy it, right? Then I go to R and I switch you guys to R as well. And then we just do like this. And now I can check. So vector 2a is 1 to 10, which is not surprising. This is 11 to 20. That's perfectly fine. Vector 2c is from 1 to 100, stepping by 5, which means that 100 is not in the list because, of course, after 96, doing plus 5 will lead to 101, and we said that we only wanted to go to 100. So here are all of the numbers from 1 to 100 when stepping by 5. And then we have vector 2d, which is the even letters. So the even letters are B, D, F, H, J, L, N, P, R, T, V, X, and Z. And if we want to have the uneven letters, we can do the same thing, right? So we can do letters, but now we start from 1. So these are the uneven letters. So A is uneven, B is even, C is uneven, D is even again. So that's how this works. So I hope everyone was able to kind of figure this one out. This is the trickiest one because you have to kind of combine two things together, right? The first thing is that you have to realize that letters is just a vector, exactly the same like the vectors that we made above, and that you can just use the sec function to get all of the even numbers from 2 to 26 or the uneven numbers from 1 to 26. And today we will learn a way actually to make this even shorter, because selecting even and uneven numbers, you can do it even easier instead of doing it like this. Alright, so let's go back to Notepad. So next question was to ask for the class, right? Just so that you guys can practice a little bit with the type system again. So the class of vector 2a is of course just using the class function and then throwing in vector2a. And then we can ask questions about this, and this will be very useful in the rest of the lecture when we start writing if statements. So to do something based on the class of an object. So we can say is numeric, is character, and is factor. Right, so in this case, this one should be true, and the other two should be false, because vector2a is a numeric vector. Then I wanted to show you guys that when you take vector2a, right, which is a numeric vector, and then you take a vector2d, which is a character vector, when you combine a numeric vector with a character vector, it will upgrade this because a vector can only have one type. And I'm now supplying the C function with two different types, and then it will select the highest type, because a logical value can be stored in a numeric value, and a numeric value can be stored in a character value, but a character value cannot be stored in a numeric value because there's more characters than that there are more or less numbers, right? Because a character value can be anything. All right, then the next one is just do the square root function of all of the numbers from 1 to 10, right? And the square root function works on vectors. And this is one of these things that is unique to R, or almost unique to R. There are a couple of other programming languages like MATLAB that can also do this, but a lot of programming languages do not allow you to take the square root of a vector. I did class vector2a and it said integer. What does that mean? So R makes a distinction between whole numbers and fractionated numbers, so numbers would have a fraction. So an integer is a whole number, and this holds for the vector, right? Because all of the numbers in vector2a are whole numbers. So it will tell you that, so it's kind of a subclass again, right? I told you that a logical can be stored in a numeric value, and a numeric value can be stored in a character value. But internally, R treats whole numbers slightly different as floating point numbers, because a whole number requires less storage space. So everything in R is there to minimize the storage space. So numeric data types are actually split into two different data types. The integer data types, which are the whole numbers, and then you have the floating point data types, which are the broken numbers, like 2.5 or 3.6. So if we would run this code, right, and just go to R, let you guys go to R as well, right? So when we just copy it in, then it says that, in my case, it says that the class of vector2a is numeric. I don't know exactly why it makes sometimes the decision to make it numeric or integer, but I think that there is an integer function as well. Integer function as well. Vector2a. So for some reason, R doesn't believe that my numbers are whole numbers. So internally, it has stored it as floating point numbers, but it can store it in both ways. So in your case, it decided that it didn't want to use as much memory, so it stored it as integer numbers. So numbers without anything behind the decimal point. But hey, if we ask the question, is this an integer? Then it should say yes, because it actually is. But it doesn't. So for some reason, my R just upgrades everything to numeric. But underwater in R, numerics can come into two different forms. So integer forms, which means that they have nothing behind the comma, and floating point, which means that they have a section behind the comma. But generally in R, we completely ignore this. We completely ignore the fact that we have integers and floating point numbers. No, because in R, the whole group of numbers is just called numerics. So it probably, I think that that's actually an interesting question. So in theory, we could look into that and see why in your case it told you it's an integer. Because it should not actually. It should actually tell you that it's a numeric. But it might be that you're using a slightly different version of R, or that you installed the 32-bit version of R. Because the 32-bit version of R is much more aggressive in optimizing the memory used. So that will, it is more likely to force stuff to the lowest type possible. Maybe I used 1 to 10. That might be the case. Let me see, because then it should say class of vector to b, right? Yeah, yeah, no. So that's then the reason why it did. Yeah. So because the double point operator, so then it should do the same thing for the sec function, right? So if we do class sec 1 to 10 by 1, then it's a numeric again, which is a little bit strange. So, but there's a difference between how R treats whole numbers and floating point numbers, so numbers with a dot. Good. So let's go back to Notepad. Right, so the idea is in 2F you should learn that if you have two different types, right, so a numeric type and a character type, then it will upgrade it to the highest type. And since a character can store a numeric value, but a numeric value can store a character, your class, by combining vector 2a, a numeric vector, with vector 2d, which is a character vector, the class of this should be character. So let's make sure that that's actually the case, that R really does that, and indeed it does. So in this case it did upgrade the vector to a. And if you would type just it in, or if you would just type it in, right, you would also see it, because it would start quoting the numbers in that sense. So that makes sense to me. All right, and the square root, like I told you guys, this is one of these unique features of R, is that almost all of the operators in R are vectorized. That means that they work on vectors automatically. And this is not the case in almost all other programming languages. All other programming languages, if you want to take the square root of like 100 different numbers, you have to write a for loop. So you have to say for x in 1 to the number of numbers that I have, take the square root of number 1, or of number I, and then of number 2, and then of number 3. So you have to do it manually. So you have to write the loop. But in R, this is not the case. Fortunately, in R, everything is vectorized. So we can just ask for the square root of vector 2a, and this should more or less work when we go to R. So it should give us all of the square roots. So 1, 1.4, 1.7, and then 2. So good. So that's using R as a calculator and a little bit of vector stuff. So matrix 3a is then the next question, because I want you guys to learn on how to use matrices. So of course you can just use a read table function to read a matrix from disk into R, but first I want you guys to be able to construct your matrices yourself. So you can use the matrix function. It takes the numbers that you want to put into the matrix, and then you specify the number of rows and then the number of columns. And by default, R fills it on a column-wise basis. So if I would do this, and I would go to R, and I would paste it in, then if I would now type matrix 3a, right, so show me the matrix, then you see that it puts in the numbers in a column-wise manner. If I don't want that, and I want R to do this in a row-wise manner, so fill first row 1, then row 2, which is kind of the more logical thing to do, I can say by row equals true, and this was question 3b, and I think everything here is small. So now if we look at matrix 3b, then we see that indeed it filled now the first row, then the second row, and then the third row. So there's another way of achieving the same goal, and the other way of achieving the same goal is to use the transpose function. Oh, I'm skipping one, sorry. So if I want to select the fifth column from matrix 3a, I can say square bracket, comma 5, right? So give me all of the rows from the fifth column. Here I'm asking the opposite, so I'm saying matrix 3b, give me the fifth row and then all of the columns. So by not specifying anything, I'm getting everything, which is kind of a nice thing for R. So of course this will lead to the same answers, because selecting the fifth column from 3a is the same as selecting the fifth row from matrix 3b. So if we go to R, I show you R again, then it looks like this, right? So it's the same. And I could say, well, in this case, select the fourth row, right? Or select row 2 to 4. All of these things are possible. But you have to realize that if I select a single row from a matrix, I get a vector back. But if I select multiple rows from a matrix, I get a matrix back as well, right? Because it automatically collapses to the lowest possible type. So this is not a matrix, this is a vector, right? Because one row or one column from a matrix leads to a vector. But selecting two rows or two columns from a matrix will give you back a matrix as well. So the R type system continuously tries to more or less minimize the space used in the memory of your computer to kind of use as the minimum amount of space and store the maximum amount of numbers or store the maximum amount of data. And that's something that will come back in R a lot, and this is one of these kind of built-in limitations from R, because everything in R needs to be in random access memory. Otherwise, R can't access it or can't use it. All right, so like I told you guys, if I want to imagine that I've made a matrix which I filled by column, and I think, oh, that's a mistake, then you can use the transpose function. So the transpose function we mentioned in the first lecture, and the transpose function is just a t, like the combine function is just a c. But by saying t matrix 3a, right? So matrix 3a was the matrix which is filled in a column-wise manner. It actually now takes column 1 and makes it row 1, right? So it takes the matrix, goes through the columns, and every column becomes a row in the new matrix. So I call this matrix 3a into 3b, and then I make sure to check that every item in this new matrix is equal to matrix 3b, because that was my goal, to take matrix 3a filled by column and make it similar to matrix 3b, which is filled by row. So that's 3D, so let's copy paste it in. So if we go to R, then it looks like this, right? And now it says true, 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 because all of the values are the same. So if I would just show you, well, not show you that, but show you matrix 3a underscore into 3b, right? And now you see that it indeed did what I expected it to do. So it indeed took the first column and made it the first row. All right. Then the last question is to add column names and row names. So the question was, how do I use the letters, which is a vector, to make column names for matrix 3a? So in this case, what I'm doing is I'm just saying that the column names of matrix 3a should be the first 10 letters of the alphabet. So I take the letters vector, select the first 10 elements from it, so square brackets 1 to 10, and then I assign this as the column names of matrix 3a. And then the last question, let me move that up a little bit because it kind of cut off on the screen. And then I want to do the row names, right? And the row names of my matrix, the question was how to use or how to set the first row name to measurement 1, then the second row name to measurement 2, and then the third row name to measurement 3. Well, that's how we do it like here. So we use the paste function. So the paste function takes a character and then a vector, or it takes two vectors and then it pastes them together. And it uses a separator. In this case, the standard separator of the paste function is the space, which is good enough for our purpose. Right, so for example purposes, let me just throw it into you, or throw it in R for you. Go to R. So what we see here is first we set the column names of matrix 3a to be the letters 1 to 10, and then we print the matrix, so we see that indeed it now has column names. And then we set the row names of matrix 3a using the paste function, where we take the word measurements and then paste it together with 1 to 10. And then when we look at it, then now indeed we have a matrix which has row names 1 to 10 and which has column names. So now we can use the row names to select from this matrix, which just is nicer to do, right? Because if we now say matrix 3a, give me measurement 2, and then give me column C, right? Why is that? Measurements. Sorry, I made a typo. Right now it will tell me that indeed this is from measurement 2 in column C, the value is 22. And of course, this makes more sense if you have a matrix with measurements on animals or on plants or on fish, where you can say from these fish, give me the date at which they are caught. Right? That's much nicer than saying from this matrix, select the 7th to the ninth column and then give me like row number 5. Right? If you can use names or descriptive headers, you should, because that just makes life easier for yourself. And I always try to get good row names and good column names for my matrix, so that it's easier to select. And when people read the code, it's much easier to understand what's going on. Right? Because if I take out an animal and I do that by the name of the animal, then everyone knows what I'm doing. But if I just say from this matrix, give me column or give me row number 5, and then for people it's really hard to understand what's kind of going on there because you're just selecting 5. All right. So these are my answers, and I will upload the answers. So this file, I will upload this to Moodle, of course, so that you guys can take the file and compare it to your own answers, so that we can see. And of course, if anyone has any other creative solutions and thinks, I did it in this way, is this correct as well? Probably yes. And I'm always interested in new creative solutions that you guys came up with, because sometimes the answers that students give me is really surprising and is really fun for me to see how people think. Like, I know one of the students sent in their whole assignments to me with, well, I know we are not supposed to send in assignments, but could you look at it? And that was actually quite interesting for me to see, because then I also know, or I kind of see where people go wrong. So if you have any questions and you want any feedback saying that, oh, I did it like this, is this correct, or is this okay? Just send it to me or ask it in chat and we can discuss. And there are a lot of different ways of achieving the same goal. And that's true in many programming languages, right? So there's no one way of doing things or one right way of doing things. Generally, there's like 10 or 12 ways of achieving the exact same goal. And that's not bad. It just allows you to be more creative, and it allows you to kind of develop your own programming style easier, which I think is good, because a programming language should not limit you. It should empower you to do the things that you want to do. All right, so if there's no questions about the assignments, then what are we going to talk about today? So for today, I have the following topics that I want to talk to you about, and they are also in the description down, so it should be clear for everyone what we're going to talk about. So we are going to talk a little bit more about variables in R. And then, because I wanted to make the whole analogy, which I normally have because I'm a very visual person, so I like to kind of see things in front of me, and also that holds for code. If I read other people's code, in my mind I'm starting to build little factories with conveyor belts and little trucks driving between the factories, taking boxes from one factory to the other, right? So in my mind that works really well to kind of figure out what's going on in the code, to kind of think of functions as being factories, control statements as being like conveyor belts, which are guiding things from A to B. So I want to kind of run through this analogy with your guys. And control structures, of course, I want to talk about the difference between statements and expressions, because I think that that's important, and there is an exam question about it, so you guys should know about it. And then we will talk about functions, so how to bundle up code that you have created into a function so that you can reuse this code, right? And this was kind of the big invention of the early modern day machines like the ENIAC, is that it supports subroutines, and that's another name for a function. So it's just a routine which you execute, and then after it's executed it returns the answer and it deletes everything which it used internally. So it's a really nice way of making your code accessible for other people. Then I wanted to have a couple of slides about brackets, because there's many different types of brackets in R that we are using, like round brackets, square brackets, and when we are talking about control structures and functions, we also start introducing curly brackets. So I wanted to give you one slide where on the slide it is explained for you guys when to use which bracket, so that it's not as confusing. And then I want to talk to you guys about escaping the inevitable, because when you are using the kind of double quotes in programming, then of course these have a special meaning. But sometimes you want to write text which has double quotes in there. So that's kind of a catch-22, like how do you do that? And there is an escape for that. So you can escape this inevitable pitfall. And then I wanted to talk to you guys about randomness and distribution. So how do I create reproducible randomness, right? Because we are doing science, so science is a field where we want reproducible research. So even if we are using random numbers, we want to be still able to repeat what we did and not be falling into this trap that when we generate random numbers, we get random outcomes, because we want to have our analysis be kind of repeatable, right? That's rule number one in science. And then again, like last week, I wanted to say a couple of things about clean and reusable code, because I think that that's one of these things that really helps beginning programmers to be kind of forced in how you should write clean code, so code which looks good and which kind of from the structure of the code you can see what it's doing. And then I want to talk a little bit about reusable code, which kind of ties in with functions, and so to make code which you can use over and over again, which means that you should not take the fifth column, but you should take something by name, because if you get another data set where all of a sudden the fifth column is not the fifth column anymore, then your code stops working. But if you take the column called date, then it doesn't matter which column it is. It can be the first one, can be the 11th one, right? So that's why it's useful to select things by name and not just say take the fifth column from this matrix and subtract 5, because in the next time, the next data set that you get, the fifth column might have shifted towards the seventh column. Good, so 10 minutes to 3, so we'll do a couple slides. I think we will do the variable part, and then we will have a little break, and you guys can watch some animated GIFs and you guys can listen to some music, but I want to get a little bit into the lecture, so let's start. So I told you guys variables are boxes. You can put things in and you can use this box without knowing what is in the box, right? So this is just a very generic image of a box, but it's a black box, right? So you have no idea what's in it. So we do a lot of things with these variables, right? So variables are more or less the workhorse of programming because they store stuff. They are like the messenger RNA of programming, right? So everything in programming happens via variables, and assigning things to variables, like having a variable called result, and this variable result is updated continuously by adding things from a matrix or something like that. So I just wanted to repeat for you guys, if you have a variable, you can ask for the length. So the length of an object will give you the number of elements which is in this variable, right? Because we might not know how many elements we read in from a file. We might not know how many elements the user gave to us. So it is very important to know the length of an object, because often when we have a vector, we're going to go through the vector from 1 to the end of the vector. So the end of the vector is given by the length of a vector. Matrices have, of course, a number of rows and a number of columns. I also told you guys about the str function. So if you have a very complex object, like you have a list with a matrix in there, and then on the second element of the list there's a vector, and then on the third element of the list there's another list, then the str will give you kind of a textual overview of how your object that you're currently looking at is structured. The class tells you which class or which type an object is, and is a very useful function to kind of deal with when R gives you a warning message or gives you an error saying that this is not a numeric type, right? So class can help you avoid these things by checking and saying if the class of this variable is numeric, then I can do a computation. But if the class of the object is character, then of course I cannot do a square root function because I cannot take the square root of the letter C. That makes no sense. And then of course we can go from one type to another type by using the as dot type. So as dot logical will transform something to a logical. And then we can also use the is. So is something a logical or is something a vector. So control structures are conveyor belts, right? We have boxes, so we now have the ability to write code which puts things in boxes. But we want to do something with these boxes, right? So we want to write algorithms, right? We want to say if I get a box and this box is is the PDF file of this presentation already uploaded? No. I was still drawing like little drawings for you guys until like 15 minutes before we started. So unfortunately, I haven't converted it and uploaded it yet. Do you really want me to? Because I could, because we have a break coming up. Then I can, in the break, just save it for you guys and upload it on Moodle. So then you can like write your things on the side. Let me just do that for you. So I will upload it during the break. So control structures are conveyor belts, right? So you can put stuff in boxes, but then these boxes need to go somewhere because otherwise you don't have a functioning program. So, and this is based on a fixed algorithm, right? So control structures guide the boxes to the correct destination, and you write the algorithm where boxes go. And there's only two different types of control structures. It's not entirely true, but for the sake of this lecture, we will only discuss the two major control structures. And those are branching and looping. So branching is a conveyor belt which splits into multiple branches. Looping is a conveyor belt where the conveyor belt takes the box and then kind of drops it back on the conveyor belt earlier. So there's no real, well, you can think of a conveyor belt which goes into a circle and then the box drops down below and goes through the circle again, right? So that's looping. So doing something repeatedly. So while the box is not full, bring the box around and put more stuff in it, right? That's looping. All right. So let's start with branching. So imagine that I have a box and there is something unknown in the box, right? So not me, but someone else did a statement saying that take my box and put the value true in there, or take my box and put the value 12 in there, or take my box and put the letter C in there, right? So imagine that I have no idea what was in the box. Then I can still figure out what's in the box by using branching, right? I can do an if statement, so I can do a test. So I can say, if the class of the box is a character, call a function called right on the box. So move the box to the right track of my code. If the box is not a character, then I want to move it to the left side, right? So here it is, the structure here is that you write the keyword if, so if, then between round brackets you do your statement. Your statement is something, a statement is something that evaluates to true or false. So here the class of box is, so this is the equality comparison operator, so to compare if something is equal. This is not an assignment. So there's a big difference between using is and using is. So a double is something that is a question, is equal to, while a single is assigning something to something else. So just as a basic example, if the class of the box is a character, then call the function right. Else call a function called left, and then give it the box, right? So take the box and move it to the left or move it to the right. So an if statement is relatively easy to read, but sometimes you want to have multiple branches, right? So you want to have a conveyor belt which does not split into two, but which splits into four, or which splits into six different routes for the rest of the code to take. Right, so then you can use a switch statement. So a switch statement is very similar to an if statement. The only thing is, can you give an example in R, please? Yeah, sure, I can give an example in R. So I go to Notepad++, right? Because I never write if or statements or anything in R, because that's just like, it's a multi-line statement, right? So for example, I can say run if, right? So run if draws a random number. So give me one random number. And I have to save this, otherwise I don't have code highlighting. So example.r. No, call it example2.r. All right, so I have v, right? So I make a variable and I put a random number in there. So when I run this code in R, like this, then I have no idea what's in v, right? So when I check v, it's 0.6. But if I do the statement again, I draw a new random number, so now it can be anything, 0.57. So imagine that I now want to check if the number in v is smaller than 0.5, right? So I can say if v is smaller than 0.5, I want to do something, right? So I want to, for example, say cut, or I want to say print. Let's do cut. V is smaller than 0.5. Right, and else, right, so if v is not smaller than 0.5, I want to do something else, and I want to say, for example, I am a robot. I don't know, like, you can print anything to the screen that you want. Right, so now what I'm doing is I'm drawing a number. I have no idea what the number is, and I check. So I use an if statement to check, and if it's smaller than 0.5, then I print this, and if it is larger than 0.5, then I say I am a robot. So now when I run this code in R, right, so I copy paste the code, and then I go to R, and I paste it in, right, then first time it says I am a robot. So now I know that v is going to be larger than 0.5, which it is. It's 0.7. I can run the code again, and it says again I'm a robot. So v again is larger than 0.5. And I can run this code all over again, and every time it will tell me if v is larger or smaller than 0.5. Is that a good example? Although it says I'm a robot, but that's just what I came up with. Right? I can do, normally you would do computation with it, right? So you would do, for example, the square root, right? So imagine that you have a mathematical function that if so the square root you can't take from negative numbers, so you would use an if statement to protect against something like that, right? So you would say if the number is larger than 0, do the square root, else give me a warning. So that's one of these more logical things, or a more reasonable example. But this is kind of how it works. So, and an if statement is really good when you want to branch into two. If you want to branch into more, then we have to use the switch statement, or we have to use an else if, which we will explain on the next slide. Good. So with this and with this little example, I think that we are at 3 o'clock. So we are. So for you guys, I prepared a really nice set of animated GIFs. And the first one, because I did this morning, is going to be elephants, I think. Yeah, I need coffee. I need a little bit of sugar as well. So yeah, you guys get some coffee or whatever you do, like take a toilet break or something like that, and enjoy the elephant animated GIFs. And GIFs of boxes on conveyor belts. I wish that there were nice GIFs like that, but unfortunately, like, they're not. So I actually thought about drawing a conveyor belt, but I gave up this morning when people started bothering me for other analysis. But doesn't matter. So you guys get to watch elephants for like 7 to 8 minutes, and then I will be back, and then we will continue with control structures. So we will continue with first with branching, and then we will go and into looping. And there's going to be music. I hope that I don't get copyright thinged again like last week, which took me like a little bit of stress. But we got the copyright thing removed because I have my equipment that I bought. So, well, I didn't buy it. I got it as a present. But that protects me against kind of copyright strikes because it comes with a library of music that I'm freely able to use on YouTube. But last week it went a little bit horribly wrong. Anyway, that's not of your concern. So you guys enjoy the short break, 10 minutes. I will run down, get a cigarette. I will try and upload the slides so that Blubbery Blub can actually make live notes, which is a perfectly reasonable request. So I will put them on Moodle. So see you guys in around 10 minutes and enjoy the coffee break and the elephants. All right, I ran. But I did get the lecture up on Moodle. So if you refresh Moodle, there should now be lecture 2 more introduction. So there should be a PDF file that you can use to put your notes on. So I hope that worked. So welcome back. Thank you guys for still being here after the nice elephants and all the other stuff. Let me do that. Good. So first part, we talked about the if. So let's make the if statement a little bit more complex. So we can do if something, do this, else do something else. If we have more than one thing, we can use the switch statement. If we have more than one thing that we want to do, we can also use else if. So we can also make multiple routes. So the switch statement that I just showed you guys, right, which is really short and nice and clean, you can also write it like this. So you can say if the class of the box is his character, go to the right, else if, and then again have a new check, the class of the box is his logical, go to the middle, and then all the other boxes I call and send to the left, right, by using the function left. So this is the way that you can add more than one clause to an if statement. So you can use multiple routes or multiple clauses. So you can say, well, I want to treat characters differently from numerics, and I want to treat numerics different from logicals. Good. So I hope this is clear. Like the else if is something that you just have to practice. This is something that you get good at if statements if you write a couple of them. And during the assignments there will be a couple of if statements that I want you guys to write, and there will be a couple of if statements or switch statements where you can use the else if as well. But this is something that it's something that you just have to learn by doing. Right? I can show you like 10 different if else statements, but in the end, you have your own kind of problem that you want to solve. So for data analysis, that the if and the else statement, they define your algorithm. So each algorithm is suited for a specific type of data or a specific structure of data. So what if we want to do more or different comparisons, right? So we can say, for example, if x is smaller than 5, so that's the thing that we just used in the little example, only we use 0.5, and then we can say x is smaller than 5, right? And of course, the statement in the if statement, so the thing that we are testing, has to evaluate to a single logical value. So it can only be true or it can only be false. So we can't use an if statement easily when we are dealing with vectors, right? If we have 10 numbers, then saying if 1 to 10 is smaller than 5, that doesn't work, right? Because then we have 10 times a true or a false value. So you have to be aware that when you do an if statement, it has to evaluate to a single true or a single false statement. We can also do the same thing when we have two variables, right? So we can say if variable x is smaller than variable y, then we can then print something to the screen. We can also use, of course, vectors, but then we have to realize that what we want is to be any or all. So we can say if all of the numbers in x are smaller than 5, then we want to print this. If we are okay with not all of them being smaller than 5, but we require that at least one of them is smaller than 5, then we can use the any statement. So we can say if any number in x is smaller than 5. Right? So in this case, we kind of read from the inside out, which is a very common thing in mathematics, but also in programming. Right? You read from the inside to the outside. So we check if the numbers of x are smaller than 5, and then we check if any of these are true. So let me give you a quick example on that, just to show you guys how that works. Right? So if we have the numbers 1 to 10, right, then we can say 1 to 10, smaller than 5, and then it will say true, 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 false, 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 right? Because the first ones are. So now if I ask all, then it will say false, because not all of the numbers are smaller than 5. But I can ask the question any number smaller than 5, and this is of course true, because there are 4 numbers which are smaller than 5. Good. So be aware that this will become very complex at a certain point, right? Because if we have our own data, then we might want to say, um, take all of the data from my matrix where the measurement date was in 2019 and the measurement was higher than 5 and some other parameter, right? So in the end, when you're writing your own algorithms, you're building up very large and complex if statements or selection statements to select from the matrix of data that you have so that you get the subset or the exact subset that you want. Because generally we don't compare across all of the years, we just say no, do year number 2009 and then do the computation and then do the computation as well for 2010. For, while, and repeat. So if we want to do looping, right, if we want to do an operation and we want to do this operation multiple times, then we can do this using a for loop or we can do this using a while loop. So for example, imagine that we have a variable called box and we put 1,000 into the box, right? Then we can now say, well, I want to take the value 1 out of the box. And then I want to take 2 out of the box. And then I want to take 3 out of the box. And then I want to take 4 out of the box, right? So if I want to, every time I want to open up the box, take something out, and then close it again. And then in the end, I want to know how much is left. So imagine that I want to do this not one time, but I want to do this 10 times, right? So I first want to take the value 1 out of the box, then the value 2, then the value 3, then the value 4, then the value 5, and then in the end I want to see what's left. So I can write this down as an algorithm by saying for x, and x is a new variable that I define, and this variable is only available to me within the for loop. So the for loop itself, this is the statement, and here is the beginning. So the curly brackets denote the block of code that belongs to it. Just like in the if statement, right? In the if statement, we also have this curly bracket, and then the if statement ends here. So within this if statement, I know that x is smaller than 5. After this statement, I don't know that anymore because it's not inside of the curly brackets. So for x in 1 to 10, right? So do this 10 times. The first time that I go through the loop, so the first time that I execute the thing between the curly brackets, x has the value of 1. The second time, x has the value of 2. So now what I'm going to do is say, well, I'm going to take the box, right? Remove an X amount of items from it, and then I'm going to store this into the box again. Right, so I'm just going to override the value that I had, right? So the first time that this happens, it will say 1,000 minus 1 is 999. Then the next time that I go through it, it will say 999 minus 2 is 997, and so on. Until it reaches 10, it will execute, and then we can continue from below. So you can use a for statement when you know how many times you want to do something. So generally, if you have a data matrix, right, with your own data, then you might want to do something for each of the rows in the matrix or for each of the columns in a matrix. So then you would say for x in 1 to the number of columns of my matrix, and then take out the first column or take out the second column or the third column, right? Because it will then go loop through every column of your matrix. You can do the same thing with a while loop. So why are there two ways of doing this? Well, when you know how often you want to do something, you can use a for loop. But if you don't know how often you are going to do something, then you need to use the while, because the while loop just checks if something is true. So it will continue looping until the statement is not true anymore. So if the statement is true, then it will continue. If the statement is false, then it will stop. So if I want to write the same algorithm, which is relatively short here, using a for loop, if I want to write the same algorithm and I want to write it using a while, then I now need two variables, because I need to have my box variable, which I put 1,000 in. And then I need to have another variable, which is the variable that is going to be the number of elements that I'm going to take out. Right, so that's why I call it take out. And the first time that I'm going to take out something from the box, I'm going to take out 1. That's why I'm assigning 1 here to take out. And now I write my statement, so I say while the variable take out is smaller than or equal to 10, execute these 2 lines of code, right? So within this block there are 2 expressions, and for each expression will be executed, and every time I execute that this is executed, I know that the takeout value is going to be smaller than or equal to 10. So again, I do the same thing as I did before. So I take my box, I do minus the number of elements that I want to take out. So the first time that I'm doing this, takeout is 1. And then I'm just going to store this back into the box. And then in the while statement, I have to now remember to manually upgrade my takeout variable, because the second time I need to take out 2 elements, right? So I have to say take out so the new value of takeout will be the old value of takeout plus 1, and then store it back into takeout, right? So this means that every time that I go through this loop, takeout will be increased by 1. Since we start at 1, Leonardo Preuss asks a question: is it also possible to type takeout plus is 1? No. That is not a valid operator in R. Plus is does not exist in R. So you have to use takeout is takeout plus 1. You have to be very explicit in R. Example for while, please, if possible. Sure. What do you want to do? So let me come up with a nice little example. So for a while loop. So we can use random numbers again, right? So I can say v equals runif 1. So give me one random number, store it into v. And now I can do count, right? And count initially is 0. So what I'm trying to write now is I want to draw random numbers until I hit a random number that is higher than a certain value. So I can say while v is smaller than, for example, 0.9, I want to do something. So what do I want to do? Well, I want to update my count, right? So count is count plus 1. And then I want to draw a new random number. So I'm going to say v is runif 1. Right? So this will loop until I draw a random number which is higher than 0.9. And the amount of times that I went through the loop is stored in the count variable, right? And to make it explicit, I'm going to say cut. So I'm going to say count is count, value is, and then v. And then I'm going to add a new line, right? So I'm just going to, every time that I go through the loop, I'm going to say, wait, this has to be like this, right? So I'm going to update my count by 1. I'm going to print the value of count, the value of v, so the current random number that I drew, and then I'm going to draw a new random number. So this will just loop and loop and loop until, by chance, I have a random number which is higher than 0.9. So if I run this in R, so let me go to R, then this should spam, right? So now I saw that it actually did 3 iterations. So in the first iteration, the random number that it drew was 0.08. So that's not higher. In the second iteration, the random number that I drew was 0.74. And in the third iteration, I drew the number 0.72. So why did the loop stop? Because I'm printing the value first, and then I'm drawing a new number, right? So the number is evaluated. So I know now for sure that the current value of v after doing this loop is going to be higher than 0.9. So what was the number that was drawn? 0.93, 6 something, right? If we then run this again, then now we are very unlucky, right? So because we drew random numbers and it took 35 times to draw a random number which is higher than 0.9. The value that we ended up with now is 0.9053. Right, so every time that I draw or that I loop this code, it will randomly draw numbers. If the number that it drew was higher than 0.9, it will stop. So now I know that V is 0.9 or higher. Yeah, no worries, no worries. That's what we're here for. So ask for examples if you want to learn more. Good, so here I'm doing the box, right? So this is the for loop because I know I want to do this 10 times. And this is the while loop, and with the while loop I can continue doing something until a certain condition is met. So a little bit of an example for the for loop in this case. So imagine that I take all of the even numbers from 2 to 10. And my question is, what is the total sum of all of the even numbers from 2 to 100? Right, so I'm going to say generate all of the even numbers. I'm going to define a new variable called total. Initially, I haven't added up any numbers, so initially the total will be 0. Then for number in even, right, because this is a vector, I'm allowed to do this. I don't have to say 1, 2, the length of even or something like that. No, I can directly loop through a vector. So I'm going to say for number in even. What do I want to do? Well, I want to just take the number that I'm looking at currently, add it to the total, and then store this back into the total. So what is happening? Well, the first time that I go through the loop, then my number is going to be 2. So the total is going to be 0 plus 2 is 2. The next time I go through the loop, the number is going to be 4. So my total from the previous iteration was 2 plus 4. So now I'm going to store 6 into total. The next number is going to be 6. So I have my total from the previous time, which was 6, plus 6, which is the new number, and now I have 12. And this will continue, right? So if I'm just wanting to add up all of the even numbers from 2 to 100, I can use this for loop, and it will add up all of the numbers, and in the end I can just type in total, and it will show me what the total sum is after going through this loop. So I told you guys that there's a difference between statements and expression. So if and anything between the round brackets is called the statement, right? And the statement needs to go back, or needs to kind of collapse when we evaluate it. It needs to collapse to a true or a false value, because I need to decide if I need to execute the expression or the multiple expressions. So this is called a block. So you have a block open, so which is a curly bracket, and then you have a block closed, and you can have as many expressions in the if statement as many as you want. The same thing is for the while, right? So a while also has a statement, and then everything within the curly brackets is the expressions that belong to the while. Like these are the expressions that belong to the if. And of course, I already told you guys that statements can and will become very complex, right? So you can, for example, negate your value by saying not. So this means not a, right? So box is 1, tests if the value in the box is 1, and then I'm asking not, right? So this is equivalent to saying if not the box is 1, do this expression. You can test multiple things at the same time. So you can say if the box is larger than 1 and at the same time the value in the box is smaller than 100, I want to do something. You can also use an or statement saying that if the box is smaller than or equal to 0, or the box is larger than 100, do something. Right? So there's many different ways that you can ask questions. So what can we use? Because we have to do comparison, right? So we have to have different comparison operators. So R supports these comparison operators. So we have the equal to, which is. We have not equal to, which is not is. We have smaller than. We have larger than. We have smaller than or equal to, or larger or equal to. So those are the things that we can use. And then of course we also have the negate operator, which is the not statement. Right, so the question, the exclamation mark. So I can take any true value, and by putting an exclamation mark in front of it, it will become false. And I can take a false statement, put an exclamation mark in front, and then it will make it true. Right? So it's just inverting the answer. So if the answer is true, it will be false. If the answer is false, it will be true. So the negate statement. So here, when I showed you this example, right, here we have the NN, right, which is the AND operator. And here we have the OR operator, which is 2 times the horizontal stripe thingy. So there is a difference in R between a single AND and a double AND. And this is complex, and this will bite you in the ass a couple of times, and then you will learn by doing that when to use which one. But I can tell you a little bit on when you want to use each one of them, but I know from experience that it's for total. Can you also write yes, so the arrow and the is symbol are equivalent to each other. So I can show you why I use an is here. And for me, I always try to use the arrow operator when I'm making a new variable, and I use the is operator when I'm updating a variable. And that is just something that I learned, or I do myself. Some people never do it. Some people always use the arrow. Some people always use is. They are completely equivalent to each other. But for me, I like when I see my code, I like to have a difference between when I'm creating a new variable or when I'm updating an old one. So for me, when I create a new one, I use the arrow. When I update an old one, I use the is. And I'm not 100% consistent in that, because like you can find code online that I wrote where this is not 100% true, but I try to kind of be diligent, and every time that I'm defining a new one, use the arrow. Updating something that is already defined, then I'm going to use the is one. But yeah, you can write the arrow. That's totally legit and will totally work. All right, so the and. Right, so the single and is vectorized. This means that you can use it for logical vectors. So it will take 2 logical vectors and then do the AND operator for each one of these in between. So it allows you to do statements and allows you to select from vectors. The double AND is not vectorized. It takes the first element from a vector, and you have to make sure yourself that you only use it in single values. Someone taught me always be consistent. I try to be, but of course there's no such thing as 100% consistency. And so coming back to the and the ors, you have 2 different types of ands and 2 different types of ors in R. So one of them is vectorized, meaning that you can use it with vectors, and the other one is not vectorized. So my rule of thumb is always, if you are writing an if statement, you use the double ampersand symbol. If you're writing a statement where you are selecting from a vector, then you use the single AND statement. And this is something that you just kind of have to learn by practicing. I can explain this, I can give you a couple of examples, but in the end you just have to run against it a couple of times. So you just have to make the mistake, use the wrong AND symbol, and then R will more or less tell you. But the idea is that if I have v1, right, and v1 is a vector, then I can now ask 2 statements at the same time. So I can say v1 smaller than 4 and v1 larger than 2, right? So this only holds for the number 3, right? So the answer here is false, false, true, false, false, right? Because the only number in v1 which adheres to this statement is the number 3. So the double one, and is not vectorized. So if I have true and false, then this evaluates to false. If I have a vector and I use the ampersand symbol, so the double ampersand symbol, so I have a vector which is true in the first position, false in the second position, and I'm going to say and true, it will only look at the first one. And it will also issue a warning. So if you have an if statement, you need a single logical value. So when you are writing an if statement, always use the double ampersand when you're wanting to ask is something and something. So the output from a single ampersand or the single or statement cannot be used directly. So the if statement will just take the first comparison, but it will issue a warning message. So when you do an if statement and you use the wrong one, so the single horizontal line for or instead of the double horizontal line for the non-vectorized or, you will get this warning message saying that the condition has length larger than 1 and only the first element will be used. So if you get this warning message, take it very serious. It is not a critical, but it means that there's something wrong in your code, and in general it means that you're using the vectorized version of the ampersand or the vectorized version of the horizontal or statement. Good. So I hope that that's clear, and we will run against this, or you guys will encounter this during the assignment. So there is a very there's a specific assignment that's there to kind of trick you guys in using the wrong one. And if you use the right one, you don't get the warning message. But be very, very diligent. If R issues a warning message, really check if this is what you want to do. Because in 95% of the cases, it is not what you want to do. And R issues warnings for a reason. So take warnings very seriously. So why do we have this ampersand symbol? It is to do in-vector comparisons. So to select from a vector some things that I want to have. Right? So for example, I have a vector which is, so a logical vector, a true-false vector, can be used as an index to a normal vector. So here, for example, I'm creating a variable called 10 to 1, which contains the numbers 10 to 1. So you can use the double point operator also in the other direction. It's not just 1 to 10, but also 10 to 1 works. And now I can ask the question 10 to 1 smaller than 5. So which value stored in this variable is smaller than 5? Right? Then it will say false, 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 true, 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 true. Right? Because only the last 4 are smaller than 5. I can directly use this logical vector as an index to 10 to 1. Because often I'm not interested in which ones are smaller than 5. I just want to take out all of the values smaller than 5, right? To make a subset. So not use the whole vector, but only use the vector for the values which are smaller than 5. So how do I do this? So this is a very common idiom in R, where you see a variable with a question, and then the answer to this is directly used as the index to the same vector on which the question was asked. Right? So 10 to 1 smaller than 5. This will be false, 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 true, 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 true. And then you can use this to select from the vector the correct values. So let me show you guys how that works in R. So let me first go to Notepad, just as a little example. So for example, I have in X, I have the numbers 1 to 100, right? And now I want to say X, X smaller than 30. Right? So if I would do this, then now I expect that the return of this, so what is printed is the values 1 to 29. Right? So if I would copy and I would go to R, then it would look like this, right? And now it indeed selects only the values from 1 to 29. And I can do it more complex, right? Because I can now use the vectorized operation. So I can say, and X is larger than 10. And now it will only give me the values to which this adheres to. And I can even make it more complex. And I can say, and X needs to be, for example, divisible or needs to be even, right? So X, Euclidean division 2, is 0. And now I only have the even ones, right? So I can just keep on asking questions, and in the end I have a single line of code which takes 100 numbers, then takes all of the numbers smaller than 30, larger than 10, and the number which is equal, or which is even, right? So because when you Euclidean divide a number by 2 and there is no remainder, then it means that the number is even. If I want to do the same thing and want to get the odd numbers, I can actually do is 1, right? Because 3 Euclidean division 2 means that there's a remainder of 1. 5 Euclidean division 2 means that there's a remainder of 1. So these are the odd numbers from a vector with 100 numbers, smaller than 30, larger than 10, where they are odd. So you can build up code statements like this. So that's what I'm trying to show you guys with this slide. You can even use a little trick, because if you have a logical vector, right, like this logical vector has a length of 10. So this here, when I'm using it, it will select the numbers which are true. But I can actually use a smaller logical vector. I can say I have two values, one which is true, one which is false. And then if they do not have the same length, then what R will do is from the vector 10 to 1, it will select the first element because it's true. For the second element, it will be false, so that one will not be selected. But for the third element, it will go back to this little vector and then say, well, the third element is true. The fourth element is false. The fifth element is true. The sixth element is false, right? So it will loop around. So this is also a way of selecting the even numbers, just by saying 10 to 1, C true, comma false. It's just the way it is. But it's tricky, right? Because here it will not even issue a warning, while I think it should issue a warning, right? Because you're trying to select from a vector using a vector which is smaller. And then it starts looping around in the small vector, like extending this, just copying the small vector every time until it has the length of the long vector. So I'm not too happy that this does not give you a warning. But this is a relatively well-used trick in R, where you can make a subset selection from a vector just using a smaller kind of true-false thing, saying I want only the even ones or I want only the uneven ones. Right, so in R we can write a single one-liner, and so instead of doing it like this, I could say give me the numbers 1 to 100, right? Combine these together and then give me all of the values which are even. So in this case I can say false, comma true, right? So 1 is false, 2 is true, 3 is false, 4 is true. And then it will give me all of the even numbers from 1 to 100. Right, so the whole letters assignment that you guys had can also be written down like this, where you take the even letters. If you want to take the odd letters, you can actually do it like this. So just turn them around. So say first element is true, second element is false. So this is a little bit tricky and a little bit mathematical. I just wanted to show you guys that you are aware that this is possible. And selecting from a vector is something that you will do a lot. Selecting from a matrix is the same thing, right? Because generally when you're dealing with data, you need to make certain subsets. So take all of the animals that are below 20 weeks of age, which have a body weight larger than 30 grams, and which have wings and are not born on a certain day, right? So these statements can and will become very, very complex. So I already showed you guys this, so you can combine these vector statements, right? So the pairwise and or the pairwise or had to do the same thing as what we did before. So we can say 10 to 1 is 10 to 1, and then larger than 3, smaller than 7, and then we can even assign this to a vector or to a new variable, and then use this variable to select from 10 to 1, right? And you can do this in vector as well, so you don't have to make this new variable subset, you can directly put it in. But generally it's cleaner to have a variable which you use as the selection criteria for your code. So vectorized statements, you're going to use them a lot, and it will just take you some time in practicing because it's just complex and you just have to be doing it a couple of times, and at a certain point it clicks and then you're like, oh yeah, no, this is how I select from a vector. Or from a matrix for that matter. So this works for matrices as well. So just a small example. If I have matrix 1, which is the matrix of the numbers 1 to 9, 3 rows, 3 columns, I can say, for example, from matrix 1, take the first column, and then which numbers in the first column are smaller than 3. Right, so those are that's the number. So I'm taking the first column, so that's 1, 2, 3. So then I'm saying which of these numbers are smaller than 3, so that's 1 and 2. And then I can use this variable to directly subset my matrix, and now I have matrix 1, column 1 lower than 3, comma, right? So take all of the rows for which are true, and drop the rows which are false, and then I get a subset of my matrix. Of course, I can do the same thing, and I can also select from matrix 1, take column 1, which of these values is 3, and then select this from matrix 1 as well. So in this case, we have a vector because now only one of the rows is selected. So when you select 2 or more rows, this returns a matrix. When you select one row, this will always return a vector. Good. So normally this is where the break is, but we're running a little bit behind schedule because I didn't plan on doing the assignments, but that's okay. We can just take a little bit more time. So I told you that there are only 2 types of control structures, and I already told you at that point that I'm lying a little bit because there are more types of control structures in R. So there are some special control structures, like the warning. So you can have, for example, an if statement checking if x is smaller than or equal to 0, and then you can issue a warning. You can say, well, hey, if I'm writing code and someone else is using my code, they should be informed that by providing a function of x, or by providing a value of x which is smaller or equal to 0, stuff might go horribly wrong. Right? Because I might have tested my code and I know that my code works for numbers which are larger than 0. It works perfect, there's no bug whatsoever, but I never tested it for numbers below 0. So then I issue a warning saying that, well, you're on your own now, right? So be aware that I didn't test this and this might go horribly wrong. Of course, you might want to give a more descriptive warning message saying why it might go wrong, but this is when you haven't tested it. If you know that stuff will go horribly wrong, don't use a warning, use an error. So an error is kind of a hard bailout. If you call the stop function, R will stop the computation and directly return to the parent scope. So it will quit and it will break all of the computation, and you will just be dumped back to the terminal for the next command. And it of course will print the error. So an error is also a control structure, right? Because it allows you to control the flow of the boxes. So the error or the stop function is more or less like the big red button in a factory, and if you push it, right, the whole factory shuts down and everyone walks outside. While the warning is just you press the warning button and a siren goes off, but everyone keeps working. So to deal with warnings and errors, you can also have the TryCatch statement. And this is very, very advanced. This is something that generally people don't discuss in lecture number 2, but since we're talking about control structures, I want you guys to be aware that there is a TryCatch. So if you have an expression which might cause an error, you can actually ignore the error, right? So you can say TryCatch, for example, take the square root of a negative number, right? This will cause an error. And then you can say error is, and then this is a new function that you are creating, and then it will say, in this case, print trying to recover. So it will kind of eat up the error, right? So it's like someone pushes the error thing, everyone starts walking outside, but there's a guy that says, no, there's nothing wrong, just continue on. So the TryCatch statement is very, very complex, and I just wanted to show you guys how it is written down in R, in case you need it in the future. But we're probably only going to write it once during the assignment. But it's something that is very, very advanced, and only in like lecture number 7 or lecture number 8 does it really start coming up, right? When we start talking about statistics, sometimes you want to do a t-test for every row in the matrix. But doing a t-test when there are less than 3 values will be an error, right? Because a t-test is only valid when you are comparing 3 versus 3. But if you're going through a matrix which is a million entries, you don't want to get your error at entry 23. Just because it cannot do the test at number 23 doesn't mean that you don't want to do it for all of the other ones, right? So in this case, you can wrap your t-test in a try-catch statement saying that just try to do the t-test. If you get an error, just continue with the next one, right? So and that's a way that you can do this, right? Because otherwise you would have to first check if there are enough numbers and all of the other requirements. But you can just say, no, just be dumb, right? For every row in my matrix, do the t-test. If there is an error, just continue with the next row. Good. So short overview. Variables are boxes. They store things. Control structures manage program flow. So you have branching, going to the left, going to the right, testing if something is true. Based on this, you want to do either A or you want to do B or C. And then we have looping, and looping is kind of a control structure which folds back on itself. So for or while something is true, so for every column in the matrix, do something. While the user is giving me numbers, do something, right? And the user can then give an infinite number of numbers, and at a certain point we want to stop when the user gives a certain number. But the while loop is used when you don't know how often you should do things, while the for loop is used when you do know how often you want to do something. So the for loop is the most general one because often you are dealing with data that comes from a matrix or from another source, and then you just want to say for each row in the matrix or for each column in the matrix. And then we have warnings and errors. Warnings and errors are control structures because they do change the flow of the algorithm, but they are more severe, right? It's not an if statement. It's not a looping. No, it's saying that, well, something might go wrong or something will go wrong. So please be careful from this point on. Good. So let's have a little vote in the chat to see how many people are still awake. Do we want to go and do the break now? Or do we want to continue for 10 more minutes and then do the break in the middle of the next section? So the next section is functions, relatively complex as well, but something that is fun. But you guys throw into the chat, also if you're on the Zoom thing, just throw in the chat, say that you're awake, and just say break or continue. Then I get a little bit of a count of how many people are still here, and we can decide if we want to break now or if we want to break in like 10 minutes. So let me be the first one so that people are not shy. I am going to say break. I don't know. 10. What's 10, Davida? 10 is break or continue? Continue probably, right? Continue for another 10 minutes. Oh, guys, it's such beautiful weather. Like, break outside, yeah. Break. No comment, don't mind. I don't know what the weather is at your place, Misha, but here it's so super sunny, so I really just want to run outside for like 10 minutes and just enjoy the sun a little bit. All right. So Davida, you say continue. You're the only one. No, Helen Niyama is also saying in 10 minutes. All right. 50-50. Nah, it's not really 50-50 because I voted for break as well. Frog, Sorreo, Leonor, Bruce. Okay, so yeah, this is kind of 50-50. All right. I'm going to make an executive decision and I'm going to say we are going to take a break. So let's just do a break. Oh, the weather is 50-50. Yeah, I'm very sorry about you. The total Zoom vote came up with break. So everyone on the Zoom voted break. So just so that you guys on YouTube know, you were overruled by the Zoom vote, which is nice because no one can see it because no one's logged into the Zoom, or almost no one. Good. So we will have a short break. Again, like 7 to 10 minutes, depending on which song I start in. And let me see if I remember. So the second break is going to be ducks. So duck and cover while the ducks are going to entertain you guys for 10 minutes. So we'll be back in 7 to 10 minutes. Enjoy the ducks. All right. I hope you guys enjoyed the ducks. Duck, 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 duck. All right. I had to duck a lot. I was like chased by this really annoying wasp outside, so that chased me around half of the campus before I got rid of it. Um, anyway, let's continue. So, third part of the lecture, and we're going to ramp up the difficulty a little bit because we now know about variables. We know about control structures, and I wanted to talk to you guys about functions. First, some advanced looping, and this is going to go back in another lecture. So there's more ways of looping in R. Like I told you guys, R provides a lot of different ways of doing the same thing. So hey, we can use the lapply function. So we can linearly apply to x, and x here is a vector, a certain function, and then we do dot dot dot, which are the additional parameters that we can specify. I think I encountered the same wasp this morning. Yeah, I think it's been haunting campus for the last couple of days. I've encountered it a couple of times, and it's a really big one. It's like one of these, like, so you don't want to get stung by one of those. So we can also apply to a matrix. So if we want to go through a matrix and we want to go through the rows or we want to go through the columns, then we can use this system as well. So instead of writing a for loop or writing a while loop, we can say apply to x. X here should be a matrix. Then we have to specify the margin. So the margin is, if you fill in a 1, then you say do for each row. If you fill in a 2, then you say do for each column. And then the fun is a function that you want to apply. So I'm going to give you guys a very quick example for this because it will come back, but I think it's good to show you guys, right? So I can say x1 to 10, right? So this is a vector. So I can lapply to my vector x, for example, a certain function, and the function could be the divide function, and then I want to divide by 8. Right? So what this will do, it will go through all of the numbers in the vector called x, and then it will divide them by 8. So if I would run this in R, then we would see something like this, where it should output all of the numbers divided by 8, and then we see that we get 1 divided by 8, 2 divided by 8, all the way to 10 divided by 8. So we can do the same thing for a matrix. So for example, if we have a matrix, so we say matrix, give me 100 numbers, so 1 to 100, 10, well, do 20 rows, 5 columns, and I call this M, right? And then I can say apply to m to 1 to the rows, for example, the function mean, right? So calculate for each row the mean of the row. So if I would go to R, then it would show you guys something like this, right? So for each row, it will now calculate the mean. If I want to calculate the mean for each column, I just replace the 1 by a 2. So I just go now through the columns, and this will calculate the different means of the column of the matrix. So every column in the matrix. So the first column has a mean of 10.5. The first row has a mean of 41. So just to show you guys the matrix. So the matrix looks like this, right? I just filled it with the column. Good. I actually had an example. So if I make a list, because lapply also works for lists, so I can say I have a list. In the first element of the list, I have a vector of 1 to 5. In the second element of the list, I have a vector from 1 to 3, or 1, 2, 3, and then the missing value. Then I can, for example, calculate the mean for each element in my list. So I can say lapply my list mean. So the first mean will be 3. The second mean will be NA, because you can't calculate a mean when one of the values is missing, right? Then the mean is also missing. So you can fix this by using na.rm, which is remove NAs. So hey, it just says that, well, ignore NAs when you calculate the mean. So now when we do this command, we say lapply, so linearly apply to my list the mean function, and every time that you encounter an NA, remove it. So now it will say that the mean of the first vector is 5, the mean of the second vector is 2. And because of the double brackets, you can see that the return type of lapply is a list in this case, because it is double brackets 1, double brackets 2, so this is the first element, second element of my list. Because it doesn't have names, right? So if I would name it, then it would be okay, because then it would specify the name. A little example of apply, very similar to what we just did. So from the matrix, fill it with 1 to 50, 10 rows, 5 columns, call this my matrix. Then we can apply to my matrix to the rows the mean, and then we can apply to my matrix to the columns my mean. And then I never use this C12, so because you can go through the rows and the column at the same time, but I've never used this at all. So just forget about the fact that this exists. So if there's a question on the exam asking if the margin is set to 2, what does it mean? Then you say, well, because we set the margin to 2, it means that we execute the function for each column. And if it's set to 1, then we execute the function for each row. So lapply and apply are sometimes more efficient. Well, not sometimes, but they are almost always more efficient, because R knows what you're going to do. Because with a for loop, it can't really know what you're going to do. But when you use lapply, it knows that you're going to do something for each element in the vector. And with apply, it knows that you're going to do something for each row or column of the matrix. So it can allocate beforehand the number of elements that you are going to return. So it's a little bit more efficient. And the nice thing is that there are also parallel versions of lapply and apply. So meaning that you can use multi-core CPUs very easily. And like we said, or like I showed you guys, if you want to execute an arithmetic function, like the plus function, then you should quote it. Otherwise, R doesn't understand what you want to do. So if I say lapply to the vector 1, 2, which is just a vector which has 2 numbers, the function plus, and then 5, then what it will do, it will do 1 plus 5, and it will do 2 plus 5, so it will return 6 and 7. But they will come back, and they are very, very useful for a lot of things, and they are very, very quick. Sometimes things take, well, hours when you just write a for loop, and it can finish in like under 10 minutes when you use the lapply or the apply function, just because they are more efficient computationally, because it knows beforehand how many results there's going to be. So lapply and apply will normally give back a list, And generally you don't want to deal with lists because lists are annoying because they have different they can contain different things at each of the elements. So for example, if we're doing this lapply to the vector 1, 2, the plus of 5, then we can unlist it to get a vector back, right? So here we see that we get a list back with the first element containing a vector of length 1, containing the value 6. We get at the second element of the thing that we get returned, we get a vector of length 1 with the value of 7, but we can use unlist to make this into a vector again. And unlist is a very, very powerful function because you can do much more than just making a list into a vector, right? So going from a list to a vector, you can use unlist, but you can do much more things with unlist. So it is a very, very powerful tool together with lapply to deal with data manipulation. Good. So to complete the analogy, right? Because we now know that variables are boxes, control structures are conveyor belts, and in my mind, functions are factories. So a factory can contain many boxes, but these boxes are not available or visible outside of the function. So this means that you can reuse variable names because generally you have to assign numbers to variables, right, to work with the variables afterwards. And the problem is, of course, is that there are only so many unique words. And in the end, if you would have one big script and you would just write it from beginning to end, then at a certain point you would run into issues because you've already used X, or you've already used I, or you've already used your variable name that is your favorite variable name. So to prevent this, functions can kind of encapsulate pieces of code. Everything inside of the function is not visible from the outside. So you can have a function with the same name, or you can have a variable inside of a function with the same name as a variable outside of the function. And changing the variable inside of the function will not change the variable outside of the function. So, and this is called the scope of a variable, because a variable lives in a certain scope. It exists throughout the session if I just define it in R. But if I define a variable inside of a function, then this variable is not visible from the outside. So we can build factories. They can contain many different boxes. These boxes are not visible from the outside. So we can use variable names, which we already used inside of a function. And this is called scope. So how does this now fit together? So factories contain boxes and conveyor belts, right? Because a factory also contains conveyor belts. And there are some limitations on functions in R. So we can have multiple variables going into a function. So multiple boxes can go in. And this is called function parameters, right? We can have all kinds of boxes for intermediate computation within our function, and this is called local variables. So these variables are local to the function that we are defining. And in R, there is a limitation because each factory can only give you back one box. So only one variable or one thing can come out of a function, and this is called the returned value. And the returned value can be very complex. You can return a list with hundreds of items in there, but you can only return one list. You can't return two lists because then these two lists need to be in a single list. So we'll get to that. It's relatively abstract, right? But in the end, we will make it more concrete by giving you a couple of examples on how this works. So we define a function in R by using the function keyword, and we return a box using the special control statement return. So return is another control statement. So we have if, or so we have branching, we have looping, we have warnings, we have errors, and we have return values. So let's give you a small example of a function. So this is the most basic function that you can come up, well, you can come up with much easier functions, but just as an example, right? So I'm creating here a function which is called box factory. So this is a variable, right? So to this variable, I assign a function, and this function takes as an input three different things. 3 different boxes. Then the function starts here, right? And the function ends all the way here. So I'm defining a scope. So I'm defining inside of this function, and anything that it define, all of the new things that it define inside of this function is not visible to the outside. So here what I'm doing is I'm doing some computation. So I'm taking box 1, subtracting box 2, and then multiplying by box 3. And then I'm storing this into a new variable called fbox. So this fbox is a box which only lives within the factory. So if I execute the function, fbox will not be defined in R. It will do the computation, put it in the box, do the rest of the function, and then it will just throw away the box because it totally forgets about it. And then I can return things. So I can say if the first box is smaller than the second box, return box 1. Else if box number 2 is smaller than box number 3, return box number 2. And if none of these two statements are true, right? So if box 1 is not smaller than box 2, if box 2 is not smaller than box 3, then return this temporary box. Then return the value of this temporary box. Right? So this is an example of a function. This function has 3 function parameters, box 1, box 2, and box 3, and it has one local variable called fbox, and at each point when I return, I can only return the value of one of the variables. Those are the rules in R that you just have to play by. Good. So a little bit more theory, because in the end we have an exam and I don't want you guys to just write code on the exam. I also want you guys to know something about programming, right? So there is computer theory here. So computer theory means that there are different ways of how we handle these boxes, right? So if I have input parameters, so this only adheres to input parameters, box 1, box 2, and box 3. So if I have these boxes, then I can give the variable to the function. And now what happens to this variable can be done in 2 ways. I can pass it by value. So that means that when I give a box to the factory doesn't take the box inside, but what it does, it just takes everything from the box and puts it in a new box. So the original box remains untouched. And it takes the new box into the factory, does all of the things with there, and then in the end it throws out a new box. So this is called pass by value. So that means that the function parameters get copied into the function, and changing them inside of the function does not alter the state of the variable that was passed. So a lot of programming languages choose this approach because it is a very sane approach, because by giving a variable to a function, nothing changes once the function ends. Right? So internally the function can do all kinds of things with this box, but the value that was originally in the box will still be in the box when the function ends. Other programming languages like C or D or C++, they take another approach. They take the pass by reference approach, which means that function parameters are the real boxes that were given, right? So they are references to the variable passed into the function. And changing anything to this box alters the state of the variable that was passed. And this is called pass by reference. And this is very useful, but very dangerous, because here we're dealing with something which is kind of called pointers in like languages like C. And these can have very surprising effects, because that means that a function can be written and this function can have side effects, meaning that by giving a certain variable to the function, after the function ends, the value that you gave to the function can have been updated. R does it slightly different. So R doesn't use pass by value, it doesn't use pass by reference, it uses a structure called pass by promise. So that means that function parameters are references to the variables passed into the function, and only when you change them is there a copy made. And this way the state of the variable that was passed is never changed into the function. So that's the way that R does it. But I want you guys to know that there's a real difference between pass by value and pass by function, because it really depends. And this is not useful for R because R doesn't use any of these two, but it is useful for when you start learning other programming languages. Because at a certain point, there are things that R is just very bad at. Things like memory management or comparing strings or doing string manipulation. There are much better languages to do that. So if you switch to a language like Python, which is pass by value, then nothing really changes because it functions more or less the same as that R functions. It's just that it uses more memory because you always copy the box. R only copies the box when you change it. But if you switch to a language like C or C++, then there is the option to pass things by reference. And then it becomes really interesting because then all of a sudden you give a variable to a function, and then once the function is done, your variable is completely different. It's completely changed. So there's a different value in it all of a sudden. And this can be very surprising to people that learn R first and then learn other programming languages. People that come from a C background or have C++ experience, they are used to pass by reference. So they are very aware of the fact that there are two different ways of dealing with function parameters. But people that generally program R, they are not aware. So once they start programming another language like C or C++ or D, they run into this big surprise that they expect nothing to change by calling a function. Just the computation takes place and then a value is returned. But in C and C++, pass by reference is more or less the default. And then you can be very surprised by an input parameter suddenly changing the global state of your program. So just some theory. Inside R, parameters get copied when changed inside a function. And this causes some serious issues because this is called pass by promise, but memory and memory usage is one of the big issues that R always struggles with. Right? So updating a variable inside of a function, so updating, so here we have an example function, right? So it's an example function, so we assign to this variable a function. It takes one variable, p1, right? So when I do p1, right, and I multiply p1 by 8, and then I store it into this internal variable, p2, nothing changes. P1 is still a reference to my var, which I input into the function. But as soon as I assign something to P1, a copy is made. And this becomes interesting, especially when you're dealing with very big data sets. When you're dealing with very big data sets, you don't want to have them copied. If I have, for example, my data set loaded and my data set is like 4 gigs in memory, then I don't all of a sudden want to start copying 4 gigs of memory just because I want to update a single value into a matrix, right? Because then all of a sudden the program that I wrote is using 8 gigs of memory, and I might not have 8 gigs in my computer, so it will just at that point just say error, cannot allocate more memory than you have, right? So there is a real reason not to do this. So the easiest would be is to say, well, forget about it, never assign to a function parameter. But that's a little bit wasteful in a way because sometimes there's no issue, right? If it's a single value, copying a single value is no big deal. But if you copy a big matrix, so if you have a function which works on a massive matrix, then you have to be very careful by reassigning to that matrix. So here we have, for example, my var, right? So my var is 5. We give this variable to my example function. So what happens is that p1 is actually a reference to my var. So here we say my var times 8, store it in p2. And then we do p2 plus 5, and now we store it in p1. So at this point, R will make a copy. So it will now, instead of using like 8 bytes of memory, it will start using 16 bytes of memory. And then if we execute the function, then the result of the function is 45. But my var has not changed. My var still contains the value of 5. And in C, this would not be the case. If you would write this function in C, and you would execute it, then my var in the end would be 45 in C. while in Python it would be 5. In R it would be 5 as well. Good. So just a little bit of theory, because I think that it's good to know what kind of the idea behind it is, because the people who wrote R have certain ideas of how you need to protect against certain bugs, certain common mistakes that programmers make. So programmers really like to reuse variables a lot, even in C++ or even in Python. So people tend to call variables x and use x all over the place for iterating through things, or I or j. But of course, if you expect a function to not change your variable and all of a sudden it does, then of course you can run into very subtle bugs where the answer in the end is completely wrong. So R protects you by this because R uses the pass by promise system. Good. So a little bit more about function parameters. In R, we can have function parameters and we can set default parameters. So we can set reasonable defaults for some function parameters. For example, if we have an alpha level in biology, our standard alpha level is 0.05. If we have false discovery rate, then we can say, well, I always want to use a false discovery rate of 10 unless the user tells me that he wants to use a different level. If, for example, nperm, which stands for number of permutations, right? If I want to randomize my data set, then I can say my number of permutations is 1,000. So here I have my exp variable, which I assign the value of 5. So this is exp, and this is my exponent, which is in the parent scope of the function. So it's not inside of the function at this point. Then I define some function, and I assign the function to it, and this function has an in parameter, so this is the first input parameter. Then we have the second input parameter, which is called exponent, and I assign the value of 2 to this by default. Then of course I do the computation, so I take my first parameter, raise it to the power of exponent, store it in an internal box, and then I return the internal variable. Right, so when I call some function 5, it will return 25. It will just do 5 to the power of 2 because exponent is standard 2. I can also call some function 5, exp, so give it the value of 5, and then of course it will do 5 to the power of 5, which is 3125, but exp is exponent, nothing changes, exp still remains the same because I don't touch it, it's not copied, it's just a reference. So it's very efficient memory wise to do this. So why do you want to use default parameters? Well, it saves other people from having to fill in all of the parameters. Like the plot function in R has, I think, almost 73 parameters. And of course, when you make a plot, you don't want to fill in all 73 parameters. So 72 of the 73 parameters of the plot function have default values. So it has a default point size, it has a default font, a default color, a default, and all of these things you can override if you want to. But if you don't want to, you can call the function plot 1 to 10 and it will make a plot of 1 to 10. So it allows you to make functions that you give to other people that are as small as possible. Furthermore, we have this ... parameter to functions. So this means that your function is now a variadic function. So a function can be variadic in R, and a variadic function is a function which accepts a variable number of arguments. So if I have no idea how many numbers someone is going to give to my function, I need to use variadic arguments. So we have already seen this because when we looked at the sum function, no, I didn't think we looked at the sum function. So we can use ... to make our own variadic functions in R, but there are a lot of functions in R which are variadic, which have things like sum. Right, so if I would give you an example, or if we would just look at the sum function, right? If I would look at the sum function, then you can see that in R this is defined as a function which takes a variable number of input parameters and has a named parameter called na.remove, which standardly defaults to false. So standard, the sum function is not going to ignore NAs. But this now allows me to do sum 1 3, 4, 5, 6, 7, 8, 9, 10. Right? So it will just sum everything up. And of course, I cannot define I cannot define a function without defining how many input parameters there are. But using dot dot dot, I can say there are, I don't know how many input parameters. In this case, there are like 8 or 9, but there could be 20, there could be 100. Right? So this allows me to define these kinds of functions when I don't know how many elements the user would like to add up, or how many elements the user is going to provide to me. So a little example, if I would implement the sum function myself, calling it mySum, I say mySum, and I assign to this a function which has a variable number of arguments. So how do I now access these variable number of arguments? Well, first off, I define my function, starts here, ends here. Since we're going to sum up things, initially I need to have a variable which contains the sum so far, right? Because I have to keep track of how many elements I already added up and what the total is. So I have count, which is the number or the total count so far. Right, so I can say for x in list dot dot dot. So give me a list of all of the parameters that the user inputted. And what am I going to do? Well, I'm just going to say, well, I take my count, I add up x, and then I store it in count. Right, so it's just summing up everything. And of course, this will be executed an unknown amount of time, but I know how many, because as soon as the user calls the function, I know how many parameters he gave. So if I do mySum and I don't provide any parameters, then of course the sum will be 0 because the list will be empty. But if I give it 3 numbers, then it will add these 3 numbers together. And I can give it 5 numbers, I can give it 7 numbers, or I can give it 100 numbers. So variadic functions are doable in R. You can write them yourself, and it's very useful for when you want to provide a function, but you have no idea how many elements your user will provide to you. So another example of variadic functions, hey, this is the kind of minimal variadic function that you can make. So you can say variadic test is a variable which contains a function which takes an unknown number of input parameters, and I'm just going to return a list of all of the input parameters. So when I now call this function and say param1 is 15, then it will say I give you back a list. The first element of the list has the name param1, value 15. I can now call it with first parameter being 15, second parameter being called test, and this is a vector 1 to 10, and then it will return to you a list which contains the first parameter and the test parameter. So just to show you guys how the dot 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 parameter works. So we talked a little bit about scope already, but to expand on scope is that stuff or variables which are defined inside of functions are not visible from the outside. So if I define again a function called sum function, I assign to this a function which is a single input parameter. I then do the input parameter to the power of 2, store it in intern, and then I return this internal box. Then when I execute the function with the value 5, it will do 5 to the power of 2. But now when I type intern, it says object intern is not found, because it is not visible from the outside, right? And this is very useful because it will clean up memory after itself. So you don't have to deal with like large data sets floating around. No, when the function finishes, everything which was internally defined is kind of cleaned up by the R system. And so it's not visible from the outside, and this is called scope. We can, however, access variables in our parent scope. So in a function, you are allowed to access variables which are not input parameters, are not internally defined, but which are already defined in, for example, the R session. But this is considered very bad practice. And sometimes we really need to do this, especially when we are dealing with big data. Right, so there's 3 possible reasons to break scope encapsulation. That's what it's called. So to break outside of your own scope. The first reason is that you're being lazy, and that's not a good reason. The other reason is to save RAM, so to save random access memory. So we're dealing with DNA or RNA sequencing data, which is very, very big data, or we're dealing with like hundreds of microarrays, then of course we don't want to copy hundreds of microarrays in data because we have already loaded our data in R, and now we're calling a function which, for example, normalizes the data. Then we don't want to all of a sudden duplicate the memory usage, because if we have 16 gigs loaded, then all of a sudden duplicating it will use 32 gigs, and then the computer will just run out of memory. And plot functions also use this system to read environmental settings. Read, for example, what the current color of the background is, or read what the current selected plot symbol is. So also plotting functions have a reason to not read inside, to read outside of their own scope. So Misha said, I use GC after a loop with a lot I use ones like sensor data. Yeah, so GC just forces a GC collection. So if you have a lot of data, then you start running into the limits of R. And I know that it's a little bit far to talk about this in the second lecture that we're doing, but I do think that you have to be aware that programming is something that you do to analyze data. And most of the people that follow the course are people that are doing biology, right? Where I'm from a biology department, so I deal with DNA sequencing data a lot. And if you're in biology, then dealing with DNA sequencing data is going to come up at some point in your career. And sequencing data is literally hard drives full of data. So dealing with these amounts of data requires you to think about what you are doing before you even start doing it. So before you start writing code, you have to think about, okay, so what am I going to do? So how much data do I have? How much memory does my computer have? Right? If I have a hard drive with sequencing data, which is 200 terabytes, then like I'm never ever going to be able to buy that much random access memory. So then either I can't use R, or I have to use R in such a way that I use it smart and that I don't run into these massive issues. And it's not just when you're dealing with DNA or RNA sequencing data, right? When you have very small things, they can explode to very big things. So if I'm dealing with things like correlation matrices, right? And I have 10,000 things, and I want to calculate 10,000 versus 10,000 correlations, then of course this is already going to be big data, because it just explodes. The same thing holds for principal component analysis. Many of these analysis tools that we use on a daily basis, they are very limited by the amount of memory that you have in your computer. So this is an example of just being lazy, right? So here I define a variable called exponent, I assign the value of 5 to it, then I write a function, and this function takes a single input parameter, but here we see exponent, right? So it's again just taking the input parameter, doing it to the power of the exponent, storing this in intern, and returning intern. And this is something that you have to avoid at all cost. All of the variable names that you use inside of your function should be either input parameters, or they should be temporarily defined variables inside of the function. Because if you do it like this, then you can sneakily change. Because if the expectation of other people is that if you call a function with a certain value, it should always return the same thing. So if I call some function 5, then this should always return 3125. But if I now change the value of exponent, then all of a sudden calling the same function with the same parameter will give me a different value back, right? If I define exponent to be 2, then now calling some function with the value 5 will all of a sudden give me back 25, right? And this is very surprising to other programmers or other people using your code. And generally this leads to massive bugs, which in the end can lead to hundreds of thousands of euros in damages. So never ever do this. If you're writing a function, make sure that all the variables that you use inside of the function are defined as input parameters or are defined as local variables, so local internal function variables. So how should the function have looked like? Well, we should have just defined exponent as an input parameter. And here we see the usefulness, because I can have a variable called exponent on the outside and I can have a variable of exponent in the inside, and now they don't conflict. They're two different variables according to R. One of them is a global variable defined in the global scope, and the other one is a variable which is defined as an input parameter. So inside of the function, it will always take the input parameter, even if it has the same name as the global variable. So this is how the function should have looked like. So hey, you should have not been lazy. You should have typed the extra input parameter into the function. Good. So we talked a lot about functions. You guys are going to write a couple of functions. You guys are going to do some while loops. You guys are going to do some for loops during the assignments. And this is just to practice. So by now we've seen a lot of different brackets in R. So round brackets are used when you call a function, right? So when we use the... Please give another example of the exponent thing. Sure. Well, what do you want to see? So let's just do some live coding. Right, so a lot of people say, why should you write functions? Right, so because if I have, for example, a function, right? So let's make a function that does at least something useful, right? So let's call it, a name of the function is going to be, all right, it's going to be, all right, so is a function, right? And this function takes as an input a parameter a and a parameter b, right? And it's going to do something, so it's going to multiply a with b, and let's make a good function, right? So let's make a good function that really does something. So generally you write functions after you've written some code, right? So I don't want to give away one of the assignments because I want you guys to kind of struggle with it. So let's do something like a box, right? So let's print out a box. So let's call it doBox, right? So doBox is a function. It takes a single parameter which is called endRow. That's a bad value because that's a n.row, right? And standard, the box contains 5 rows, right? So I'm going to say for x in 1, 2, n.row, right? I'm going to do something. And what am I going to do? Well, I'm going to cut. And what am I going to cut? So I'm going to cut x's. Just a couple with a new line behind it, right? So now I can say doBox, right? And default parameter will make sure that I now print 5 lines of x's, so it looks like kind of a squarey thingy in R, right? So if we go to R, then doBox makes a little box, right? And we can now do a new parameter, and this parameter can be like 50, right? So now we do a big box or a big row of x's, right? You have to use a little bit of imagination. So if we go back to Notepad, right, then we can do a second parameter, which is called the length, right? So let's call it b.length, right? b.length standard is also 5, and now here, instead of doing x's, and then I want to do a set number of b length. So I'm going to say repeat the value x, and how often do I want to repeat x? I want to do b.length, right? And then this is my x row or something like that, right? And now I'm going to cut. So I'm going to cut x row with a new line. Right, so now I have 2 parameters. The first one defines how many rows I'm going to do, and the second one defines how many x's there are on a row. So if I now do doBox, then it will print a box which is 5 by 5. Right, and it adds spaces to it, so that's perfectly fine. That's just the cut function at work. Oh, you guys can see it, sorry. So if I do box, then, and now I can define, so I want to do a box, and I want to, for example, do a box which is 6 by 9, right? Then it looks like this. I can do a box which is 9 by 6, and then it looks like this, right? So now, of course, when we're dealing with these variables, I could just say, well, I'm going to be lazy, and I'm going to define my b length being 5 first, right? And now when I call my function, then I will take the b length from here, right? So I can now say, for example, b length is 5, then execute the doBox function with 6. Right, and now I can redefine my b length to be 15, and then I'm going to say doBox 6. Right, so any normal person would expect that when I call doBox 6 and doBox 6, that it would return the exact same thing. But because of the fact that here I'm using b length, which is not defined as an input parameter, now these two functions will do completely different things. Which is of course very unexpected, because the only way to know that this doBox is actually dependent on b length is to read the code of the function. But the idea of writing functions is to kind of hide the implementation for the user, right? So by making doBox depend on a variable which is defined, I actually run into issues. It even becomes worse when I clear R, right? So when I say edit, there's an option. So when I just remove all of the objects in R, right? So now b.length is not defined, right? It's not found. So now when I call my function doBox, so I have to paste it in first. So when I create my function and I now call doBox 6, then actually it gives me an error, which no one expects, because like it only has one input parameter, right? And I filled in the input parameter, so the function should just work. But it does not work. Why? Because the function is dependent on this b length variable, which should be an input parameter, but it's not, because it reads it from the parent scope. And there are some good reasons to do this. I've used like reading and writing from the parent environment sometimes when you're dealing with big data. Um, it's not very common, but it is common enough that I want to stress this is if you write a function, all of the variables used inside of the function should either be input parameters or they should be internal temporary variables like xrow, right? It's fine to use xrow here because xrow is defined within the function. So it's something that like goes wrong a lot of the times. So that's why when I talk about functions, I do want to kind of hammer in that don't do this. Write proper code. Don't make your code depend on some magic variable that the user needs to define, because it can be very tricky, and calling the same function with the same parameter should always give you the same answer, unless it depends on random numbers, of course. But even then, we have ways of dealing with that. Good, so let's continue with the PowerPoint. Right, so brackets. We see in a lot of brackets, round brackets. You use them when you call functions, and you use them when you do control structures. Right, so for example, when I do the if statement. So if round bracket, and then inside of the round bracket is the statement that I want to check. Right, so a round bracket is generally something that is used in functions when you call a function, when you define a function parameter list, or when you do statements in control structures. So the square brackets are when you index vectors, matrices, or data frames. The double square brackets are when you index a list. And the curly brackets, they define blocks of codes. And this is used to surround expressions, so we know which expression belongs to the if statement, or which expressions belong inside of the function. Right, so it signifies a beginning and an end of a block of code. So at the end of so at the closing bracket here, R will know, okay, so now the if statement is done, or the while statement is done, or the function is done. So just as a handy overview for you guys so that you can kind of look up which bracket should I use. Because I know from the assignments, because the current assignments will be relatively hard. And that is, I think, good because you can only learn programming when you kind of run against problems that you either have to Google or that you have to kind of figure out. But if you just do assignments, right, and the assignments is just following or typing in code that some other person gives you, you never learn how to program. Learning how to program is kind of struggling with errors, figuring out what the errors means, fixing the errors. That's where kind of the whole Erfolgserlebnis from programming comes from. For if statement, do I need to use idents and curly brackets? Yes. Clean code means that you want to make clear where something starts and where something ends, right? So in this doBox function, which I'm going to fix because it's now a bad function because it depends on something else, right? So when I define a square bracket, or when I do use a curly bracket, I do spaces. And when I then open up a new section of code, right? Because this is the section of code that belongs to the function, and this is the section of code which is inside of the for loop, I again do indentation. And the indentation is not necessary in R, but it is there to help you figure out what's going on. I could write this whole thing on a single line and R would not care. Because I could just say, well, I don't use indentation. I'm just going to use like this, right? And I just do just dot comma to specify where the end is. I don't even need the last one because I can just say, well, that ends there, right? But it's just clear like this. And then in theory, I think I could even put the whole thing on a single line, right? So then, but no one can understand what's going on here, right? And no one's going to zoom out this far to see your whole function definition. So work clean, right? Write small lines of code. Every line of code that you write should be visible where it starts, where it ends, where it belongs to. Okay, Leonardo Proust. Is it better to use tab or space? It does not matter from a programmer's perspective. But if you want to earn money, you use spaces. People who use spaces generally get paid 10 to 20% more money for the same job as people who use tabs. People who mix tabs and spaces get paid just as much as people who use tabs. So use spaces. Spaces earns you more money. I don't know why there was this whole Stack Overflow like big research thing that they did, and they just figured out that if you use spaces, you get more money. It's just that's science that they just did the research. They just asked, or they spidered a whole bunch of these open source repositories, and then they compared people's income to which one of the two they were using, or which one of the three, right? Because you can mix them together as well, like a crazy person. But in the end, the conclusion was, if you use spaces, you get paid 10 to 20% more money for the exact same job. So use spaces. That's all I can kind of conclude for that. But is it better? I don't know. There's no real better in this case. But do indentation. That's the important part. Make sure that when you look at code, it looks nice and clean. The thing which I like about spaces, and that's just a personal preference, is that they are not as annoying in Notepad++. Because I actually have it set up that every time that I press top, it actually will put two spaces for me. But like you can see in my editor, and I have to probably zoom in, I don't know if it's visible, but there are these little, very invisible yellow dots here. And you can make them much brighter, but trust me, they're there, right? If you look very closely, you can see that there's like 4 little dots. And in Notepad++, and to actually get a tab, I have to open up a data file, just because I don't, all my tabs automatically get, so tabs look like this in Notepad++. So if I would write the same function and I would use tabs, then it would look like this, which is okay, right? Like the indentation is still clear. You can see that this is 1 level deep, this is 2 levels deep. But I don't know. For me, spaces are where it's at. But some people like tabs, and as long as you use it consistent. Don't be a madman. Don't mix spaces and tabs together, because then like it just gets everyone crazy. But in R, there's no rule on if you should use spaces or if you use tabs. But it is one of these things. Like either one is fine. Don't mix them. It's like drinking booze, right? It's fine to drink wine. It's fine to drink beer, but don't be an asshole and start mixing them. That's just crazy. So don't be a crazy person. Good. All right, so we had almost done, right? Because we have functions, we have variables, and all of these things. And actually, after these 2 lectures, everything's complete. You can write a complete operating system by just being aware of tabs and, not of tabs and spaces, but by being aware of the fact that you have variables, you have control structures, and you have functions, and there is nothing more. There is no more magic in programming. Programming, the whole computer just does nothing else than execute if statements, do while and for loops, and besides that, there is a little bit of talking to hardware, which is also using if statements and for loops, and generally it's just executing a function. So after this lecture, like, you are fully fledged programmers and you could program anything that you want. But of course there will be more lectures just to help you guys along. Good. So this is not the last topic. The one to last topic that we have for today is escaping the inevitable. So about strings, right? They are enclosed by using double floaty things or single floaty things. We can combine strings using paste, right? We've already seen that in the first assignment when you paste measurements with a vector. You can print them to the screen in R using the function print. Like you saw in the examples, I generally use cut. So cut is exactly the same as print, but cut is nicer because it allows you to not only write to the screen, you can also directly write to a file. And generally you want to write to files because having the output on the screen is nice for when it's 5 plus 5, but when it's RNA-seq data, you want to write it to the hard drive. And using cut gives you flexibility, right? Because you can say, write it to the screen now, and then once you check that everything is okay for the first couple of lines, then you can say, okay, so now I'm going to write it to the file, and I'm going to do it for all 100,000 elements that are there. So paste is there to paste 2 things together. Print is there to print things to a screen, and cut means print them anywhere. Print them to a file, to a screen, to a printer, to the mouse. You can also cut to your mouse for some reason. It won't do anything, but the mouse, in theory, it's an output device in a way. That's more of an input device, but you can use it as an output device as well. So about strings. Forgetting to close a string happens a lot in R. And it is one of these things that people run into during the assignments, and you can struggle with it for a very, very long time. So in R, no command after will produce output. Right? So if you are in R, right? So imagine that, let me go to R, right? And in R, I'm typing, so I'm saying I have a variable and I want to put a string in and blah, 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 and something more, and then I press enter and I forgot to close it, right? And I think, okay, everything's fine. I made a string, right? So I now know that, but normally you don't know that you're missing a bracket. And now I'm typing 5 plus 5, right? And I'm like, why the hell's nothing happening? Or 5 plus 5, right? So why the hell's nothing happening? 3 plus 7. Why the hell's nothing happening? Right? Because, like, I expect there to be output. But I forgot to close my string. So the only way that you can kind of detect this little error, which comes up a lot, is to look in front. So in front you see here that input lines in R start with a larger than symbol. And when I'm still inside of something which I did not close, it uses pluses. The same thing holds for if statement. So if this happens, right, and you type stuff and nothing happens, and while you expect stuff to be computed, press the little stop button here at the top. So press stop, and now you will see it will give you a larger than symbol again. The same thing happens for if statements. So if I say if 5 smaller than 6, do something, right? So I open up a block, then the same thing holds here. So now I can say cut, and I can do something, right? And then nothing will happen until I close the bracket, right? And now it will execute the command because 5 is smaller than 6. But this plus symbol in front, and that is a clear sign, especially when you are defining strings and stuff, that something went wrong. And this is something that is very common for people who start out with programming to fall into. And sometimes this can take you 10, 15 minutes before you kind of figure out, oh shit, I should have closed my string and I didn't, and now I spent all of this time just trying to do stuff and I didn't get any output. So when you don't get any output, while you expect output, 70 to 80% of the time it's because you forgot to close a string. The other 20% of the time it is because you opened up an if statement or a block of code, right? An if statement, a while statement, or a function. And you haven't closed the final bracket yet. So if you notice in R these little plus symbols, press the stop button just to force R to stop what it's doing. So stop making a string or stop making something else. And then hey, this will really help you. And I added this slide because first time that I gave the assignments, people got stuck on defining a little string. And this becomes even more troublesome with the escaping the inevitable part. Because Helen Niyama, this explains a lot. Had a full line of plus while doing the assignment. Yeah, no, I know that it happens, so that's why I made a slide for it, because it's something that's so common that during the assignments, and when we do the assignments in person, I can just walk and say, oh, wait a second, like there's pluses, so press the stop button and try again. But that's also the reason why I tell people never to program in R. Program in Notepad++, then just copy paste it into R. The same thing can happen, but at least Notepad can help you a little bit with figuring out if something is closed or not by having like the highlighting. So it does happen a lot. And especially in this part where we are going to do string escaping. Because escaping the inevitable means that when you have, if you print two things together, then you print it to the screen. You can use cut to do the same thing, and then you can say file is out.txt, and it will directly write it to this file. But the problem comes in when we want to print this character itself to the file. It sometimes happens that you want to print the like double air quote thing, especially when you're dealing with text or other things, right? It's just a standard text character which might occur in a text. So if you want to print this thing, then we need to escape it. You need to escape the character. So there are a few characters in R that need escaping. So the ones that need escaping are quotes, so the double air quote, the single air quote, and you just escape it by putting a slash in front of it. A new line, so the enter on the keyboard, is also a text character, right? Because text contains enters. So you need to be able to put enters in text that you make. So the new line is also a escaped character. It is defined by /n. The top character, so pressing top on the keyboard, is also a normal character, which occurs a lot in text files and data files. In tab separated files, there's a lot of tab characters. So to have R output a tab separated file, you need to print or you need to cut tabs to a file. So you can do that by /t. Since the backslash character is the escape character, to print a backslash character, you have to escape it. So printing a backslash to a file or to R to the window, you need to say //. And then there's a special one, which is the backspace, which is the backspace key on your keyboard. Also, that is a typable character in R. So you can do /b to have a backspace character happening in R. So let me guys show you a couple of examples, right? So here you see that when I do cut without a new line, then the new input, so the input will continue on the line where I did the printing. This of course doesn't look very nice. So generally you say cut and you say, for example, hello world, and then you say /n, right? So now it will print, or will print the text to the screen, and it will do an enter, and then you continue on the next line instead of continuing on the same line. If we want to print hello world and then add like this floaty air thingy, or floaty air thingy, it's actually called a quote, so a double quote, right? So if we want to print a double quote behind hello world, we can do it like this, right? So now it says hello world double point space quote. If we want to do a slash, it's the same thing, so we do // right? So now we can print a slash character. We can print a top character as well, so we can do /t, and of course here we see that it just goes further apart. And we can also use the backspace character, so if we say, well, /b, because I want to remove the d from world, then this also works. Right, so now we have hello, a tab character, then world, and then the D was printed, but then backspaced out of the string. And this is the way that you can more or less build up more complex strings. So this is always very difficult. And here, especially here with the backspaced quote, the backspace double quote, this often runs into problems of having not closed strings properly. Because the string highlighting in Notepad++ can be relatively difficult. Although Notepad++ understands it, it sometimes goes wrong. So if you do something like this in Notepad++, then now it cannot figure out where the string starts or where the string ends, right? Because it doesn't know that this is an escape character. But you can only remove one letter. No, you can remove as many letters as you want using /b. Right? I could remove another one. It's just like a string is like typing on a keyboard. Right? So here, the string here says, press the H on the keyboard, press the E on the keyboard, blah, 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 blah. And then here at the world says, press the D, then press the backspace character, and now we can say, press it again. Right? So now this would remove the L as well. We can remove the whole string by just adding more /b's. Right, so we'll just eat it up. So backspace is like a string is just interpreted from left to right. So R just looks at the first letter, prints it to the screen, second letter, and so on and so on. Good. All right. So these ones need to be escaped. There are more. There's a /0, which is like the end of a string for C and C++, but these are the ones that you have to be aware of and are very commonly used in normal text, so that you have to... What is the point of /b? Well, if you send it to a printer, then /b is a reasonable character to sometimes print, right? Because you want to remove, like it's really useful in when you do a string of things, and it's relatively useful if you want to do kind of fancy stuff. I mean, you could just leave out the character you want to have deleted. Yeah, if I define a string like this, yes, but if I do it in a for loop, or if I do it in a function which I call, then I might not want to do that. And it's interesting in a way because it also allows you to do things like progress bars, right? I might want to have a function which shows me a progress bar. And if an error occurs, then I want to have the progress bar run backwards in R. And you can do that using the /b character. So it's not completely useless. There are some very, very specific needs for having a backspace character. you have a backspace on your keyboard as well, right? Like you could have just typed in the text like proper, but you made a mistake, so you have to press the backspace key. So that there's a reason why it's on your keyboard, and if there's a reason why it's on your keyboard, there's also a reason that you might want to trigger it using a program. Is that a good answer, or but because like I always wonder, I have some code that I use /b just for the fun of it, but it's not something that you use daily or something. Like it's not that. But I use the backspace character on my keyboard a lot, so during programming you might want to use it as well. And you can do really nifty, funny typewriter thingies with it, right? If you would just have like a text from a file that is a very big file that you want to print with like delays. Like we can, yeah, it's after 5, so let's just do a funny thing then, right? So display text like a 5-year-old. Right, takes as the input my text, and then you can do something like for for. So the first thing is we need to string split str split, right? Because we need to get the letters of the my text, and then these are the letters, right? And now we can say for the letters in for L in the letters. And then we can do something like cut L, and then we can say sys.sleep run if 1, and then if L. Yeah, let's just run if 1, if run if 1 smaller than 0.02. What do we want to do? Then we want to say cut a // character, and want to sleep a little bit again, right? So we want to sleep a random amount of time, and then we want to cut L again, something like this, right? So just as a little nonsensical example for the thing, so now we would have like a function which displays text like a kind of 5-year-old typing on a typewriter. So, and then we need to get a long text. So let's get a long text from somewhere. Let's just take the Moodle standard text. Argument split is missing, yes, which is like this. And then you can just say, this is the text that I wanted to do, and then display text like a 5-year-old, and then do it like this. Right, so just as a little example, we need to have some text. Yeah, let's add in some random enters as well, so we can see kind of what's happening. So we can do like cut, and then cut a /new line, just a little bit more of the time. Yeah, that's not a lot of. Why does it not do this? Cut L/B. Let's do this just more often, and do this more often as well. So this is like 30% of the time. Oh, yeah. Sys.sleep, I think it's called like that. Just don't remember the sleep thingy. I think that's the, yeah, so it's with a capital. Alright, so now it should be a little bit more fun. I don't know, why does it not? So it sleeps, then it does a run if, then it does another run if. Why does it not add new lines to? Well, anyway, so, oh, you can't see it running. Sorry, I'm not showing you the screen. Yeah, sorry. I was just coding and not looking at the. But it doesn't put in the new lines actually. So let me actually do. So this is here. So then it should be here. And then we go back to R. I have no idea why it's not cutting the new lines. Because I'm just wondering why the new lines don't get done. But and there's a lot of spaces in there as well for some weird reason. So then we do it like this, a little bit of debugging, because this would just print a whole bunch of new lines, but it just prints one. Ah, I'm sorry, unlist. I am sorry. The unlist function is very, very powerful, so you have to use it sometimes. But now it should be more or less like what I want it to do. And now it just prints a whole bunch of them. That's good. So we can just delete the hashtags for. Alright. So now we have a little function that does a little bit more. So it's just like, but still does it on one line. So let's just remove this one so that and then this one should be 2% of the time, and this one should be like 3% of, 5% of the time, right? So now it seems like just someone's typing in a typewriter, and then sometimes you have to go back, right? Like it's not something that you use a lot, and I'm just coming out of so like it's just but you can do these kinds of things, right? Like it's creative in a way. This is of course not the best way of doing it, but yeah, but it does seem now like someone's typing in a typewriter. But it it's not that useful. But for progress bar, sometimes you want a progress bar to go back, and then you use slash b. So so that's the only reason why I think it's probably in there because of the fact that you can write to printers and other machines as well, right? You can think about sensors or an external um, um, or an external device which responds to the backspace. Um, so that's probably one of the reasons why it's there. All right, let me see. How many slides do we have left? We still have 10 slides left. So we do need to do another break, I think. Very quick break, and then I do want to I do want to get through the last ones. So let's have a vote in chat again. Do we just want to plow through for another like 10 minutes and I'm just gonna not do anything interesting or not do like these kinds of things? But I'm just going to go through the slides so that I can say what I want to say about the slides. Or do we want to do a break? So throw in chat, plow through, or break. And then in the meantime, you can watch this thing like type it. And the nice thing is if you display it again, right? It because of the random numbers, it will always generate a new uh, way. PT plow through. Okay, okay. I'm up for that. I'm up for that. Like it's pizza day, so all right. Shia Valdez says slides, which is also good. Sorry, I just butchered your name. Shiavash Falizade. Is that okay? I'm wondering. So you create a sort of chatbot. PT. Okay, plow through, plow through. That's good. Okay, then we're gonna plow through. Yeah, you can. That's the nice thing, right? Like I don't know why that guy came up with something like this, but you can do things with programming. So and these things don't have to be useful all of the time. They can be just for fun, and for fun you need a backspace because backspaces are cool. Otherwise they wouldn't be on your keyboard. Good. All right. So let's plow through. So we talked about string escaping. The backslash is one of them. There's probably more, right? There's probably a delete key as well. I didn't put it on here, but there's probably a delete key as well. That's probably slash D or something. But I never used that one. I did use the backslash, so just so that we know. Good. Okay, so when using cut, we print verbatim, right? Meaning we need to make sure to add at the end of the line, otherwise R continues on the same line. Not only that, but when we use cut, we can use this separator parameter to specify how we want to separate elements. Right, so we can say cut hello world. Don't forget the new line, separators, comma, so we say hello, comma, world. We can have cut hello world with separator being space, and we can put a separator to being minus. So there's different separators that you can set, and it will automatically use those. Good, so the last thing that I wanted to discuss for today is random numbers and random distributions, right? Because in the end, we're working in science, we want to have reproducible research, and that also means that when working with random numbers, we also want to have reproducible random numbers. And this is one of these XKCD comics where it says int get random number, return 4, right? And of course, this is a perfectly valid random number generator, even though it always returns 4, which we now know. But if we would not know the output of the function, right, and we would just say get random number, it would return 4. We would say get random number and it would return 4 again. We have no way of proving that this function is not a random number generator, because we don't know how it generates the numbers. But it's an interesting kind of thought experiment, because you can't prove that something is really random. Right? You can only say that, well, there seems to be a structure with a certain likelihood, but in the end, it could still be random. So, uniform distributions, I think everyone knows about uniform distributions, so every value has the same chance of being drawn. In R, it's the runIf function, and if you generate 10,000 to 100,000 uniform numbers, then it looks kind of like this when you make a histogram. So uniform numbers are drawn. The minimum number is 0, the maximum number is 1 inclusively. But if you look at the histogram, it means that every section of the plot has the same probability of being drawn. So that's a uniform distribution. Very much used when you have a group of students and you select one of the students to answer your question, right? Because every student has the same chance of being like you answer it, right? That's how I imagine a uniform distribution. There's the Gaussian distribution, also called the normal distribution. Values near the mean have a higher chance of being drawn. In R, you can do this using the rnorm function. So the rnorm function draws an x amount of numbers from the normal distribution. So the standard normal distribution has a mean of 0 and a standard deviation of 1. You can specify in the function parameters the mean and the standard deviation. In the runIf function, so the runiform function, you can also specify the minimum and the maximum value. So it has an n, a min, and a max, and here it has an n, a mean, and a standard deviation. Then we have the Poisson distribution. So Poisson distributions are special distributions because they are distributions that are made up of integers, so whole numbers, and numbers at the lower end of the distribution have a higher chance of occurring. And the way that I always imagine a Poisson distribution is if you would look at a bush of flowers, right? And the Poisson distribution is the number of bees on a single flower. Some flowers will have 0, or a lot of flowers will have no bees on there. Some flowers will have 1 bee on there. Some flowers will have 2, but that's already much, much less, right? So this is just the number of bees that you can observe on a flower when you look at a random flower, right? And Poisson distributions are always whole numbers because you cannot observe half a bee. Well, you could, but generally we don't consider half bees to be interesting. Good. So when we talk about randomness, we want to have repeatable randomness, right? So if we need repeatable randomness, so if we have a function, then we want randomness to repeat. So to do this, we can use this set.seed function. So the set.seed function is like resetting your graphical calculator. When I was doing mathematics in high school, then when we had an exam, everyone was forced to reset their graphical calculator. And the reason for this is one, it deletes all of the cheating nodes that are in your calculator, but it also allows the teacher to have you generate a random number and then do something with it, and then everyone in the class gets the same, right? Because everyone in the class, after resetting your graphical calculator, the first random number that you draw will always be 7. The second one will always be 9. The next one will always be 12, right? So it starts again from a fixed point. So every time that you, at least that was in my high school. So in my high school, the first thing that it said on the on the exam sheet would be, take your graphical calculator, reset it, draw 5 random numbers and write them on the piece of paper. And if you had the wrong 5 numbers, then the whole exam was invalid because you didn't reset your calculator, so they assumed that you were cheating and you had cheat nodes in your calculator. But anyone who knows a little bit about computers figured out that you didn't have to reset your graphical calculator. You could just keep your cheat nodes. You just had to make sure that you set the seed of your graphical calculator back to the factory default seed, which was just known because it was written down in the manual of your graphical calculator. So once people figured it out, everyone started cheating because everyone could use cheat nodes during math, so then they quit the whole thing with doing it. Anyway, to have repeatable randomness, you have the set.seed function. So when I set my seed to 1 in R, and I do 5 random numbers between 0 and 2, and I round them down, then I get 1, 1, 2, 0. And you can check this in R, right? So you can go to your R window, you can do set.seed, you can say set.seed 1, let me show you guys R, right? And then I do round, and I do run if, and I do 5 numbers between, what was it, 0 and 2. Right? So I get exactly the same. Everyone in the world, everyone who uses R, if you set your seed to 1, you draw 5 random uniform numbers between 0 and 2, you round them down, it will always be 1, 1, 1, 2, 0. Right? So that's yeah, that's how it works, right? Because otherwise it wouldn't be repeatable. If I set my seed to 2 and I do the same thing, then I will get 0, 1, 1, 0, 2. So if I want to have repeatable randomness, the only thing that I have to remember is to set my seed back to a certain fixed number. And you can choose any number as a seed, and then from then on, all of the random numbers that you draw will always be the same until infinity. So you can draw an infinite amount of random numbers. If you set your seed, from that point on, all of the numbers will be similar. Good. So just as a tip for you guys, if you ever write algorithms or if you ever need to do something with like simulation, right, where you want to have your simulation come up with the exact same answer as the previous simulation, you can use the set.seed function and random numbers to kind of force that. Good. So again, programming is like working in a lab. Make sure you work clean, right? So that means use proper indentation. Don't be a madman. Don't start mixing spaces and tabs. Keep variable names logical. And make sure that you code in a single directory. So I always have 3 folders on any project that I do here as a professional programmer. So I have one folder where I put all of the input data. And this folder, when I'm on Linux, I make this folder read only to make sure that the valuable input data that we spend tens of thousands of euros on collecting or doing samples and then sending it for sequencing, when I get that data, I put it somewhere and I make it read only, just to make sure that I don't accidentally overwrite my input data. All of the code that I have goes into another directory, and this whole directory is put into version control. Any output data that my code generates is put into another directory, not into the input data folder. just to prevent overwriting input files and losing hundreds of thousands of euros of data. And that can happen at the blink of an eye with a computer, especially when you're not paying attention or when you're programming on a Sunday. So don't be that guy that deletes 5 years of work or 10 years of work of a lab just by not making sure that the input data is set to read only and that it's in its own folder, in its own directory on the hard drive, right? It happens. It happens to the best of us. Like NASA lost moon landers because of dumb programming errors. So make sure that you're not that guy that screws up the whole lab. Good. Clean code also means that you have to think of speaking names for variables and functions. Things like mysum, count, or total, or and those are names which you can do something with. Don't be that guy that leaves behind code which is called variables called AA or ABA or XXA or these kinds of things. It does not save you time in the end. It just makes it harder for yourself. When you code more than a couple of years, going back to your old code, being able to read it and understand it without having to figure out what XI, II, IJ, and JI mean is like a time saver. You will think yourself not now but in the future. Now it will feel like an extra chore. But in 12 years, when you look back on your code, you will be happy that you came up with good names. Use indentation to denote blocks. Use spaces because you earn more money. Align your comments. Comments should align at the end. You are not a madman. We are dealing like with coding as being in a lab. We are professionals. So use indentation, right? So when I open up a block, everything goes 2 spaces forward. When I open up another block, everything goes another 2 spaces forward. Make code readable for others. Don't be that guy that writes the next Facebook and then loses everything because no one else can understand your code and no one else can maintain it. Good. So in science, we need reproducible results. So make sure you can run a script without errors. So write your answers in Notepad++ or write it in another editor. At the end of the day, do Control A, Control C, go to R, do Control V. It should run from beginning to end without any errors or warnings. And that's the way that I try to do my coding. So in general, and I'm now going to do something very stupid because you should never do a live demo. So when I go to Notepad, right, and I go and I say view and I want to have my folder as a workshop, and I go, for example, to a random project that I have on my hard drive, like data analysis for Texas. Or I can go to, for example, whatever we want. Whatever we want. So we go to code that I wrote for Nicole, which is very, very old code. Yeah, so this won't work because it's still on my D drive. I don't have a D drive anymore. So, but in theory that should work. But let's take some more like random code, right? So let's go to hemolysis expression, right? This is my code. And my code, I should just be able to do this, right? So Control A, Control C, go to R, fingers crossed, right? That I don't like mess up myself. So copy paste, right? Should run from beginning to end without having any errors, right? That's the way that you should write code. Also, use speaking names, mean 11, mean 17, right? Data kidney, parental kidney, right? It makes sense. You can read, you can understand what's happening, right? This is Biomart, so we're doing stuff. So I just reran part of my analysis and I'm 100% confident that it worked because it just runs from beginning to end. So write code like that. That is really important. Because if you are working as a programmer or a bioinformatician in a group, your professor will come to you in 2.5 years and will ask you, could you rerun that analysis that you wrote 2.5 years ago? And you look like a jackass if you say, no, I can't. Well, not just that, but you might actually lose your job because in the end, you are there to make sure that everything works. So be a professional. Spend the time now, don't spend the time later. That's it. Any questions? Any remarks? Any comments? Any likes? Any dislikes? By the way, you guys can like the video. It really helps for discoverability on YouTube. And I want to thank you guys for being here. It's been a long one, but I think we managed to get through. Thank you guys for the questions. I really like having questions because it just makes it more interactive and it allows me to write a little function that lets me output text like a 5-year-old who does use the backspace key and doesn't type it in perfectly. And I am going to do another try. It's called Si Ya Vash. That's okay, right? Si Ya Vash. Yeah. Yeah, I try. I try. No worries. So thank you guys for being here. If there's no questions, I will just hang around a little bit. Just you guys might come up with questions. It's a Persian name. Yeah, it's a nice name. I like it. Although I butchered it the first time that I tried to say it. I actually wonder why you call yourself Shia in emails. That it's like if you have a good name, strong name, use the whole thing. All right, Davida. Yeah, see you around. And do the assignments, of course. The assignments are not on Moodle yet. I will directly upload them so that you guys can start. Let me actually do that live because I did change some little things in the assignments again this year, just to make sure that no one can go away with, well, to avoid the butchering part. Yeah, that's a good reason. Let me go to our course and then we go to assignments 2. And I will then save it as a. So the assignments are relatively difficult. So don't be scared off. The assignments, lecture 3 are, I think, easier than lecture 2. And it is hard, but it is just to force you guys to be professional, ask questions, and kind of really learn what it is to be a programmer, right? Because generally, you have to Google a lot, you have to do it all yourself, and the assignments are online now, at least on Moodle, and I will upload them tonight on my homepage because that takes a little bit more effort because I have to log in and these kinds of things. So thank you guys. Thank you for being there. Like without your questions, it's not as fun, and it's just the same thing as last year. And I'm here for you guys. I was a little bit disappointed that no one showed up this morning. I offered you guys that you could come and have me help you with the assignments. No one showed up. That's a little bit like sad, but in the end, like I assumed that because no one was there, that everyone did the assignments and everyone was able to finish them perfectly. And of course, if you want to have some feedback on your assignments, I'm also more than willing to look at your assignments and give you some feedback, of course. It's not that, because I say the assignments, you don't have to turn them in. But if you have a solution and you think, is this correct or am I doing anything wrong? Then I'm more than willing to help. Question from chat. What are the COVID regulations over there? Well, at least in our building, you still have to do this the whole time. So you have to wear a mask inside of the building. When you can't keep your distance, you have to wear a mask. But in Germany itself, I think the only requirement on masks is in doctor's office, hospitals, Public transport, these things still require FFP2s. For the rest, we gave up. So we just roll over and said, COVID's gone, and which I don't agree with, which I definitely don't agree with. So the rules are very minimal. I don't even think that you still need to wear a mask in like supermarkets and stuff, which is dumb. Like it's a disease that spreads via the air. It's a virus. We have no idea about the long-term effects, right? The first time that people discovered that like HIV was a thing, it was also like, yeah, well, it's just a virus. It does give you sniffles and shit. Like it's not that bad. And then like 5 to 10 years ago, or 5 to 10 years later, people started developing AIDS, and then all of a sudden was, oh my god, this is really bad. Fortunately, it's only in the gay community and not really in the whole community. COVID says, see you next fall. I think that, yeah, yeah. I'm not gonna do any like long-term predictions or stuff, but read the papers that have been published in Nature at the end of last year, especially by the guys from the Wuhan Institute of Virology, and look at how China is reacting to the current COVID outbreak, and then start realizing that we might actually be wrong and the Chinese might actually be right, and then realize what it would mean if it really turns out to be HIV like and taking over your immune system long term. I'm wearing my mask zealously from the beginning because my Chinese friends all tell me wear your mask, and my Chinese friends are good friends, so they have the best. They want the best for me. So if my friends tell me wear a mask and don't get the virus, then I will wear a mask and don't get the virus, because I think that that's the smart thing to do. But that's just my opinion. Like other people can think differently from it, but I don't know. I don't know. I'm undecided about it. But I do go outside sometimes without my mask to smoke a cigarette, and I'm not as careful as I should be probably. But we'll see. Good. So I see the viewer number dropping. So thank you guys for being there. Yeah, better safe than sorry. That's always the best approach, I think. So viewer numbers are dropping. So thank you guys for being here again. And end of the lecture, do the assignments. And if you need any help, contact me by email. Don't wait until next week in the hopes that we can do it in person. Start working already on it this weekend. It will take you somewhere between half an hour to 2.5 hours to do the assignments. All right. See you guys next time, and see you next week, at least here, and I hope in person. But if not, then next week here. All right. So catch you on the flip side.